that means actually we don't use any dashboarding tool. We don't, like if we do use, if there is a dashboarding tool that we use, it's more likely that it's like Power BI or, and it's a different team that manages that. Tableau or Spotfire. Oh, Spotfire, they know my existence. Yeah. So if there's any, I've had my teammates build demos with panel or with Plotly. That's the closest we've got. Okay. Yeah. So it's Moderna use cases are going to be potentially restricted. Yeah. But I can see the potential to teams that don't operate the way that we do. Yeah. Yeah. There's a lot of potential there.
Yeah. I'd also say in the like the panel use case kind of thing, like these widgets are sort of like the precursors, like they work in those environments too. So it's sort of like if there is one that you're using to like look at DataFrame and stuff, you can like drop it.
Yeah. Yeah. That's true. That's true. Across.
But also notebook environments. So you just spend your time to do very small.
Yeah. 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 Right. Right. Yeah.
Yeah, we should chat more.
We should chat.
Yeah. This morning.
Okay.
We'll follow up later.
All right.
Thanks for stopping by.
Yeah. You're right.
Okay. Okay, cool. It does look like it's working. So then we should just do this. I think that'll be preferred. Let me just, yeah. Can you create a code space without forking? Okay, cool. Hi, welcome.
just us and for the first 4 hours.
Okay.
Or, yeah, there's two blocks.
Yeah.
Today.
Okay, that's easy. Basically, like if you guys can stay within the white lines, you pick up on the camera without issue.
Okay.
Ideally, if you move around, by all means, move around. We'll still capture the content, no problem.
Okay.
But it's always nice to have a face with
Sure.
sometimes in the audio. And if you do, I don't know if anybody told you, but feel free to take this off and walk around with it. And like if you hold it here, it can kind of get comfortable, so that you're not thinking about this as much. But if it's out here and all that stuff and you're gesturing, it won't work.
Okay.
Yeah, and that's got batteries and everything. And then that's pretty much it as far as what we kind of need from you guys. So, any questions from us at all?
No, I don't think so. Yeah.
I'm going straight through, so we'll take care of the cut down later, there's some breaks or exercise time later.
Okay.
I'm gonna make sure that we got a good look here, and otherwise we're ready to go when you guys want to. So.
Great, thanks. Thank you.
Check, check. Hey, hey, hey. Good morning, good morning, good morning. Check, check. Hey. Good morning, good morning. This is a presentation. Welcome to SciPy. Check, check, check. Thank you guys again for presenting.
Feeling well rested today, John?
better.
How'd the tutorial go yesterday?
Pretty well.
Yeah.
It was awesome.
Thanks.
Better than well.
Cool.
I feel like if I had to make a plot today, I would be using a,
Okay, good. Good. That's the first one. Yeah, so we're trying out this GitHub code spaces for running the environments, so and using Jupyter Lab within that. So folks are able to.
yeah, I know, that's awesome.
Yeah.
Yeah, I'd never even heard of code spaces until yesterday. It's kind of blown my mind.
Yeah, Nazar went to the IBIS talk yesterday. We were like, oh, we'll do that.
Literally set this up yesterday,
so,
but it seems to work really well.
yeah.
And so it'll open by default in VS Code, which also works. If for some reason Jupyter Lab doesn't work, but I think Jupyter Lab's kind of a bit nicer for this tutorial, so you can either, after the container builds and everything, you can just append that URL in your URL and it will open Jupyter Lab. You can also go back to the UI in GitHub and you'll see your
John, I'm curious, yesterday, did you talk about the Jupyter chart?
Okay, cool.
It wasn't this big section, but
Yeah.
the interactivity, we showed how to get the selections out.
Okay, cool. Yeah, I mean, that will be sort of the, for people that saw that yesterday, we'll create the build from scratch.
Just wanted to introduce myself quickly. My name is Matt. I'll be popping in and out of the rooms over here if you have technical issues, let me know, or discussion issues. I'll try to help you out.
Awesome.
So, yeah, yeah. Then I'll end it back to your watching the story.
It's not nice to be able to see. I'll squint.
I like that they gave us the guideline. or the
Yeah.
ruler.
Yeah.
We're just- GitHub's what this morning? Sleepy. Okay.
Code space does take a while.
Oh, I mean, GitHub is not answering.
I wonder if we could use the stickers as like a indicator.
Yeah.
Like just put it in front of your computer. Yeah. Or we could do it as like
Well, one of them, how about one of them?
Sure. Yeah.
this seems like it might be nice to have the poll. Mm-hmm.
It was like about
Okay, you're not the first person to say that.
no, it was not even supposed to be able to. Yeah, mine kind of started looking a little fun.
I don't know.
All over GitHub.
It's like, oh, this is the guy. This IP. Yeah.
Use a VPN.
Let's just get them. Yeah, no, only GitHub, right? Yeah, the other one's outside.
Oh no.
If I go to VPN, let's see what happens.
GitHub down.
You take GitHub down. Okay, VPN works. Yeah, so just use a VPN.
All the instructions you posted last week, are those okay?
Yeah.
But they are if you're able to make the environment locally, yes. But you will need to pull down the latest changes from the repo, because we updated some of the notebooks yesterday.
So, I did it early this morning. Okay.
It should be fine. Yeah.
Okay, wait, you have to. All right.
Okay. I wonder if there's any. Okay, there was an issue, but it has been resolved. Allegedly. Okay. So we'll take the first like 10, 15 minutes to just make sure folks can settle in and get environments set up, and then we'll jump into the tutorial.
Those who just walked in, we'll set up our environment in GitHub code spaces. So if you just head to the tutorial repo, it's very straightforward. You just click on the code button. There's a tab that says code spaces. Click the plus, and it will just start to launch a VS Code instance. And for this tutorial, we kind of prefer Jupyter Lab, but it'll work in VS Code as well. So after your code space builds, you can just add this editor equals Jupyter to the URL, and it'll reopen it in Jupyter Lab or via the UI.
Requirement for draw data that doesn't exist in Conda form?
After it loads,
I see.
It's in your requirements, but not in your environment.
I think it's in the requirements.
Yeah, it's in the requirements, it's not in the environment.
Okay.
Here's the environment. Yep. Here are the requirements.
Oh, I see. Are you able to pip install into your Conda environment?
Yeah, I was just trying to use that file, so it will bomb out if anything.
I see. Okay, thank you. Yeah, it is in the, I see. It's in that environment.yaml, you can just delete that entry, and it should be okay.
It's in the requirements, it's not an environment YAML. This doesn't need to be deleted from environment YAML because it's not in there.
Okay. I think no, I think that because for one of the extra examples, like I included this draw data, and it's not in Conda, so that's why the environment.yaml is not working. But it shouldn't be necessary. So did you run like Conda create?
Yeah, I'd already run kind of create last week, so I'm updating my environment now with the stuff.
We just added a pip section to the environment.yaml file.
Yeah. Requirements. Let's see. So it's pip. Oh no, sorry. Not the-
anyone else who needs to get
Yeah, I think the,
Raw data is not uncommon.
yeah, but it's also not in the environment.yaml, so that's why I'm not sure what the error is.
Yeah, want to see the error? But it comes from, you have in requirements.txt draw data, which is not our content storage. So it will bomb if there's anything in the requirements that's not in the repository, right?
Right.
But conda create doesn't look at requirements.txt.
No, but Mamba install does.
Okay.
So if you try to use an environment YAML,
Mhm.
Mamba install or conda install,
Yeah.
it will bomb. It uses the requirements.txt format, does not use an environment YAML format.
Okay. I did not know that about Mamba, but we said in the instructions it's conda.
Either one. Yeah,
Okay.
the install dash file just needs a file with just the requirements. But if you have like all the YAML stuff in there, like the name and the repository and stuff like that, it will bomb.
Okay.
But otherwise, so.
It's
Oh, it's
Okay, great. Thanks.
yes, but you can also switch this to the and go back to your who does not have code space working at Windows and they try to get out of worst case, you can follow the other code. That works.
One old core and some like 2010 processor and half a gigabyte of RAM.
These needs to be a lot of cycles. Does anyone not have a Jupyter? Make sure you're signed in, otherwise code space is fine. The thing about using the stickers is a little help indicator, so if you're having trouble, put your sticker in front of your laptop.
Which one?
The bigger one.
If you need more help, put a bunch of stickers.
Yes, without the, so we're asking that we do it in Jupyter Lab. So right now this is just opening in like a code space VS Code.
Right.
So if in the URL you add this editor, !editor equals Jupyter, it will open that code space in a Jupyter Lab rather than the VS Code environment.
Y'all will see them.
Yes, yeah.
Everyone has a working environment, VS Code or Jupyter Lab. Just any stragglers left over, just raise your hand, but should probably start.
Yeah.
So what's all this over on the right here?
That's just another way to switch to Jupyter Lab. So you can either just add that to the URL or go back to the UI here after you've started your code space, click over here, and you'll see the
Click on
options.
the three dots. Okay,
Yeah.
Yeah.
gotcha.
Yeah. All right. Welcome. All right. Well, if people are ready, we can just get started. You should join. Okay, okay. Not to put you on the spot. All right, cool. Well, thanks everyone for coming. This is the anywidget SciPy tutorial for this year, and today we're going to be teaching you sort of the fundamentals of building custom Jupyter widgets of your own using anywidget. So I'm Trevor. I'm a PhD student at Harvard Medical School in the High Dive Lab. I'm one of the core contributor, I guess, to the anywidget project, and this is Nazar.
I'm an assistant professor at UMass Medical School in the Boston area. Another, basically, anywidget PI mentor.
Yeah. And just a little bit of an outline of what we'll be tackling today. So we're going to start with sort of just a demo notebook. The idea is like you can follow along, but I'm just going to open up a notebook and sort of go through it a little bit faster and just really try to motivate like why anywidget exists and sort of the problem it tries to address. Then we'll switch over to some slides explaining at a high level what anywidget is. We'll then get you right into coding and building the first widget of your own, and we'll take sort of a hello world widget and some simple examples. And then we'll have a more advanced use case that we build out from scratch and sort of a complete widget, if you will. So the goals for today are really to have you understand what is anywidget and how to use it, and really get you coding. So at the end of this, I want you to feel very competent at building widgets of your own, or at least feel like you have the tool set to, if you're in Jupyter or if you want to extend like Jupyter or sort of your programming environment with some web-based superpowers and bring that to your own Python objects, you can do that. And I think most of all, I hope everyone sort of can have fun today. Some of the examples will be quite silly, but we're just really trying to emphasize sort of the fundamentals of building these extensions of your own. So I was trying to think of something that summarized, like, hopefully the feeling that I hope that you get out of today. And we have this great community member from the anywidget community who said something recently online that I thought captured this. And the sentiment that I hope you come away with today. There's something about these widgets that really make you say, you'll never out-notebook a notebook when it comes to a lot of data science-y products out there. And really, it's just, they add a lot of oomph to what you can actually do. And what I hope today that you come out of this tutorial with is this feeling that if you feel that you, I hope that you come out of the tutorial today with the feeling that you can add that oomph if you want to sort of your environment and provide that for others folks as well. So let's just switch over to doing a little demo, and I'll motivate really like what is anywidget and in the context of Jupyter and how it works. So like I said, I have this demo notebook in the notebooks that have been shared with everyone else. This is called intro.py, so you can sort of follow along. But I'll be sort of just coding through some of these examples to motivate sort of the, like I mentioned, like where anywidget sits and what it works with. So if folks have seen the Altair tutorial, I think that maybe some of this, like the data set here might be familiar from yesterday. But really, we're going to progress through sort of the different types of visualizations that you can do in a Jupyter environment for a particular cars data set. So I have this cars data set here, which has sort of these different cars with some different features, including things like miles per gallon, their origin, their weight. And in a Jupyter environment, like some of the most familiar tools to folks to actually visualize data like this might be some sort of static visualization library. And so in this notebook, I have the Seaborn library, which I can use to create sort of a static plot of this visualization. And static plots are great. Like, they absolutely are essential for building like high quality rasterized graphics, and Matplotlib is an excellent framework. But one challenge is that they aren't very interactive, right? So when I run this cell, if I run it again, the output from this cell is an image. So it's a rendering of this data, and it's a static plot. And so when I say static, what I mean is that there's no interactivity here. It's just a JPEG. So, and if I want to adjust something, like maybe change some attribute, I can't interact with this output. I actually have to write new code and re-execute a cell to make that output change. So if I wanted to do something like change the hue to cylinders, like I actually need to rerun that cell. Or if I wanted to maybe figure out what this point is here, that seems to be sort of an outlier which has higher horsepower per miles per gallon, like actually narrowing in on that point can kind of be challenging. Like I might have to sort of eyeball how to facet my data set and actually extract that point. And so because we are in a web environment, right, so a lot of these notebook environments run and execute code in the web browser on the front end. That means that you can actually bring Java, or these environments have introduced the ability to extend the notebooks with JavaScript, HTML, and CSS, which are the building blocks in the front end for developing additional interactive user interfaces. So we can actually take this plot from before, and we can use the Altair library, and it's not important to know the syntax for this example, but what we can do is create a more interactive chart. So I can create a chart that's called points, alt.chart, and we can use our cars data set, and I'll create a mark encoding, or a point encoding. We'll copy over these parameters from before, except I'll change this to color. And now we can create sort of a simple plot with Altair, which captures the same thing from above. And the important point about this visualization is that rather than being a static rendering, this is actually rendered on the front end using a rendering library that's based in JavaScript. And so what it means is that this visualization has a lot more potential to add in interactivity. So initially, this doesn't really have any interactive elements to it, but the Altair library allows me to add things like if I want to add a tooltip, I can add that, and maybe I want to put the name of the car so that when I hover it, I can actually see what this particular car is. And so it's kind of helped in maybe this original use case of like, I want to just know what this point is, and I want to be able to look at it. So we can do other things. So Altair is like a very extensible grammar for building these visualizations, or is based on top of a grammar for building these visualizations. And I can build additional things like adding additional interactive elements to these plots. So I can take this chart from before, and I can add sort of an additional subplot to this, which allows me to use a shared selection between the two and actually sort of cross-filter my data and take a look at a subset of my data in a more interactive way. So here I can look at the count of, maybe we can do this by origin. I can just do this again, copy origin. And we can add in this is our chart. So we're going to save this plot to a chart. And now I have sort of oops, I need to add the interactive piece. So add params, sorry, brush, transform, filter, brush. And now when I select a set of points, I can actually have this more interactive plot. And so when you see this, I have sort of this concept now in this Altair chart of having this selection, right? So I have this bounding box, and it's linked to this other plot. And one intuitive thing, like as someone that's interacting with this, I'm in the notebook, and I might want to reach for something that's like, what is this selection? Like I want that data like from this visualization because maybe I want to look at that points as like a data frame in the notebook. And so if I were to run this cell, actually, like on this particular visualization, that type of interactivity doesn't exist. And that is happening because the way that these visualizations are created, it sort of is a very surface level integration into the notebook. And so although it is interactive and uses these web-based interactive rendering library, you can think of this as sort of you send data into this from this Python environment into the front end, and then all of that interactivity is trapped in the front end. So there's no good way to sort of like release that data from the JavaScript and bring it back into Python. And that's really where Jupyters can come and shine, or Jupyter Widgets shine, is that they are a framework that is like built into Jupyter to allow you to sort of connect these two worlds bidirectionally. And so when I say bidirectional, what that means is that you can interact with the plot and have that update things that are in your notebook, and also write and run notebook cells and have that update this visualization. And so it really is this way of extending Jupyter with sort of these small widgets of interactivity that can really enhance a workflow. So with any widget, we can close this loop. So so far we've shown taking the data and putting it into the front end and having this interactivity. And with any widget, we can prototype like a pretty simple widget that, that adds this functionality that we're looking for. And so we're going to go plenty into detail today of like what exactly is the API around any widget, but I just want the folks to come away from this demo is just seeing that in a few lines of code, we can add this type of interactivity that brings that data back out of the notebook. So with any widget, I can define a new chart widget, and I can grab the chart from Altair and render it ourselves. And so right now, this is the same exact rendering as before. I'm using the Altair visualization library to build this chart, but then rather than using Altair's built-in rendering, this is now using AnyWidget's rendering. And what we can do with AnyWidget is we can add additional data that we want to extract and bring from that front end back into the world. And so we define these pieces of state that we want to share between the front end and the notebook as these additional properties on our widget. So here I have something called the selection. So I'm defining that I want this dictionary that lives on the Python side, and I want that to be shared on the front end side by syncing it. So that's the two pieces here. And then within our front end code, we can actually, we then want to make sure that anytime we interact with this plot, we can update that piece of data so that we can access it in the notebook. So this is specific to how this specific rendering library works, which is called Vega Lite. And we can add a listener for when this particular property or this particular sort of selection, this brush that we have changes. And so what I can do is write a function that anytime this changes. So this is a specific event listener or something that anytime we interact with this plot, we'll call this function. And within here, we can synchronize that selection that we added down here into the model. So say model.set our selection, and we can apply the update. Then we say model.save changes to sync that back with the Python side. Changes. So now, if I select a set of data here, I can go down into the chart. And we'd say chart.selection because that's what we named the chart. Oh, sorry. We want to grab our, it's called widget. That's my apologies. So if you do widget.selection, is it add? So now when I make a selection and I move around, that function is getting called and we're synchronizing that piece of data. So if I move around and I rerun the cell, you can see that now we're getting back out that data that is being captured in that front end. So this has really completed that loop by taking that piece of state that was trapped in JavaScript and bringing it back into the Python notebook. And the cool thing about building these widgets is that they very much compose together on the Python side. So if you add that piece of functionality to expose that piece of data from JavaScript to Python, you can then connect it and reuse it in different ways. And so I just want to show a quick cell here that we're going to create a small widget that composes both this chart widget that we made and an output that is just printing the current data frame that is the current selection. So this is just a little bit of code that's coming from SciPy widgets, which is sort of a collection of really convenient, nice widgets that you can compose with your widgets of your own. And in this one, we're creating an output that anytime that selection changes, we're going to get that subset of the data frame and just print it to the output cell. So now we have our chart that has these different bars. And as we brush, we actually just get a nice data frame here at the bottom that shows what our current selection is. And so in just a few lines of code, we're able to create a sort of simple widget that brings out that piece of information that we want. And the nice thing about any widget is that it takes care of making sure that this piece of code not only works in Jupyter Lab, but any sort of notebook environment where that is based in these web-based, that is web-based. So we can actually take this code that we wrote, and we can go into something like Google Colab, where I have this notebook from before. And while that loads, we can actually show the VS Code case. So if we can actually go into VS Code, and I'm just going to run these cells from before. Sorry. I just want to make sure that we have our chart that we've defined with Altair. Cool. And we can copy and paste in that code that we just made. If we create that widget, we should have that same functionality. And you don't have to package this up in any way. You can really write these pieces of reusable code if you want and share them as notebooks, and they should reliably execute across all these different platforms.
You actually take a look at Altair now, they have a new widget front-end piece that is based on any widget that does this.
Yeah, so this is like very much just a hack to get that single selection that we added. And then the great maintainers at Altair have now added their own widget, which sort of dynamically makes sure that you can access all those different selection parameters from the chart. So there's something that's much more robust that's been upstreamed into that package. But the goal of this demo is to just highlight that, in a few lines of code, you can dig in if you want to try to sort of unleash some of this front-end stuff back into your notebook environment. Cool. So I'm just going to switch back over to a couple of slides to just capture what we talked about before we dive into actually coding up some of the widgets of our own. So I've mentioned a few terms today that I just want to clarify before, and you're going to continue to hear them throughout the rest of the day. So I just want to make sure that we're all sort of on the same page with thinking about what exactly are widgets and how they sort of work in this architecture that is Jupyter. So one of the words you might have heard me say is front end. And when I say front end, I'm talking about the actual web browser or the web browser-like thing that is executing where you actually write your code and execute the cells. So VS Code, for example, is built on a web-based technology and is where you're writing that code, and that's the front end. In the Chrome, that's going to be the Chrome is the web browser itself. And the kernel is this separate process that Jupyter orchestrates, which is running somewhere else on your machine or even on a remote machine. And so for everyone that's on Codespaces today, that remote machine, the kernel is somewhere, GitHub's hosting that somewhere. but the front end is the actual tab in your web browser where you're writing the code and executing the cells. And the interesting thing about widgets is that they really span these two worlds and connect them together. And so normally, Jupyter sort of like mediates how these two worlds talk to one another. And widgets are really this fine-grained piece where you can define a small channel to talk back and forth between that front end. And so when I say, the other word that you might hear sometimes today is bidirectional. Again, I just want to emphasize that this is really where widgets shine, because that channel between talking between the front end and kernel is, allows for communication both ways. And so that means that if I move a slider in the front end, I can get the value of that slider in the kernel. And I could also set that value of the slider from the kernel and have it updated in the front end. And widgets are really the framework for orchestrating those two pieces. And with really that primitive of having that channel, there's a lot of really cool things that people have been building with widgets. And so there's many different interactive visualization libraries that are built upon this architecture. So as I mentioned before, widgets can work in a Jupyter notebook, but then there's also a lot of these Jupyter-like things, or we call them Jupyter-compatible platforms, which are similar or share some of the architecture of Jupyter, but differ in terms of maybe the capabilities that the front ends have. And then there are all these different dashboarding libraries that have support for widgets as well. And that really is because widgets are this foundational part of like Jupyter's infrastructure, which means that like they've been around for a while and they have a lot of, they've seen wide adoption by these other frameworks. So the takeaway here is if you get something to work as a widget, people can use them in any of these sort of environments where they might want to use that. But making reusable widgets is sort of a challenge, and that is where anywidget steps in. So it really manages this compatibility problem for you by defining a smaller set of APIs for you to implement like your widgets. And so really it does this through a process of standardization and then providing a tool set to help author and distribute like the standardization. So at a very high level, you can imagine these different platforms as sort of these puzzle pieces that you have to sort of get your code to work in a particular way. And with any widget and with any potential Jupyter widget that you might write, you need to write a little bit of JavaScript code. But with any widget, this code is a little bit special. It's called ECMAScript. So it's not just JavaScript, it's actually a formal like browser-accepted specification for how JavaScript should be written and shared and distributed. And this is called ECMAScript. So anywidget's API is, for the front-end code is based upon this standardization that has been adopted by all browsers in around like 2019 or 2018. And what this means is that anywidget really defines this smaller subset of like on top of this reusable standard that can be loaded and executed across all browsers. And so you, the widget author, define a JavaScript file that exports these different hooks for anywidget. And we'll talk about what these specific functions are today, but you can think of them as just these functions that anywidget will eventually call for you in these different platforms. And they are associated with things like updating the cell and rendering the visualization or a particular view into that notebook output. And so with anywidget, you write both your front-end code and your Python code, potentially like in a file or in a notebook, and then and you write this web standard JavaScript that is amendable to anywidget sort of API. And then anywidget provides this glue code above these different platforms to make sure that that code can be executed everywhere. And so what that means is that you can write code in notebooks, you can write code in just sort of standalone files, or you can build sort of like more robust packages that use these modern frameworks or things that people like to use on the front end. But at its core, it really is built upon this like web standard thing that is built across all browsers and should be supported long term. So just as a high level about like what anywidget allows you to do, you can make reusable components that work across these different platforms. You should be able to prototype widgets within these notebook platforms. You can share your ideas as scripts or as really robust packages, which will show some of these like community projects that people have been building with anywidget. And then the cool thing about widgets is that you can remix them with anything. So because anywidgets are composed with SciPy widgets, you can really build kind of cool, extensible, interactive things without even touching front-end code by just remixing existing widgets together. So as I mentioned, just as a highlight, there's a lot of different community examples. We have them on the documentation. It might be worth checking out later today. on your free time. And before we dive into the notebooks, I know that we're at a Python conference, so I feel like taking a moment to just say, like, I love Python, and that's why I'm here. But I encourage everyone to be open-minded today about engaging with and learning a little bit of JavaScript, because I think that knowing a little bit will go a very long way in terms of being able to see ways that you could extend your own environments with sort of these web-based superpowers. And the other piece here is that we're really trying to start small because there's a lot of moving parts. So the reason why these slides are a little bit long in the beginning was to just preface, like, you have this front end, you've got this Python side, and they're talking somehow. And so there's a lot of surface area for us to cover. And we're going to focus very small and then build out. And the final, maybe this is like a philosophical idea, is that, like, I want you to focus on this, like, web platform stuff over things that you might have heard before in the front end world. So there are, like, frameworks, React, like all these kind of things that I think, like, people have probably heard of, and maybe, like, you want to try that out. I guarantee it, if you learn some of the things today, you will definitely be able to use those frameworks. But we're going to focus really on the fundamentals that make you comfortable and confident in knowing how this communication layer works, so that then you can really, like, make use of those frameworks if you want to later. But really, we want you to understand this sort of standardized communication layer, because I think that's really the important piece. And those libraries and frameworks change all the time, so it's not, I don't think, worth covering today. Okay, cool. So I think before we get started, we might take a little bit of time for questions, little 5-minute break, and then we're just going to drop into some notebooks. So thank you.
Any questions?
Yeah.
So this is mainly focused on the visualization component, or can you actually edit data within the widgets as well, and then pass in those modifications to those edits back into the Python object?
So, like,
Edit data on the front end through some UI. Yeah.
yes, so the piece that's being shared between the two environments is data. So you have a Python dictionary in the front end that ends up as a JavaScript object, and you can modify that on the front end and send that back to the notebook. Yep. So actually, some of the examples today, what we'll be doing is using some of the built-in features that are in the web browser to modify some data and send it back to Python. And so it'll be just sort of like fun examples that demonstrate really this, I think, these low-level sort of like that conceptual idea of how you build these widgets. And then if you have ideas of your own, hopefully it gives you the building blocks to build those things. You had a question as well?
Yeah, who is driving or sponsoring the development of anywidget, and how does that fit in with, you said you upstream it to Altair?
So it's basically community driven at this point. So there's actually, if you join the Discord, you'll see a lot of people that are working on it. In terms of the upstreaming, that's just not any widget itself, but the widget for Altair was upstream. So it's just being adopted.
Right, so Altair has an optional dependency, which is anywidget, for their widget functionality in that library. So I should clarify, yeah.
So basically, Trevor showed me this demo of SciPy, and then it was compelling enough to write it in Altair correctly without separate dependency.
Yep.
Yeah. The community.
Cool. Yes?
Hi, actually I haven't used any widget thing before. I saw this similar thing, SciPy widget. You also mentioned that.
Yes.
But I'm quite interested to know what is the actual difference. Is these similar things we can do with the widget?
Yes, so let's go back. I can quick do this before we jump into the demos that we'll be working on today. But with SciPy widgets provides like a collection of maybe some like common input and output, or input widgets that you might want to use within a notebook environment. So I can import SciPy widgets, and these are very like sort of basic like elements like forms, text inputs, sliders, like those come from SciPy widgets, and then you can really connect them with these more custom visualization wrappers that are what people are mostly building with anywidget. So with SciPy widgets, we can create an int slider, and we can call this like slider. And if I run this cell, you'll see that I have this like, let me get some vertical space. So if I run this cell, I have this slider here, and I can move it back and forth. And so similar to the example that we looked at before, when I made a selection, that's very similar to me dragging this piece here. So that's an interaction that's happening in that front-end world. And then the SciPy widgets framework is taking care of taking that value and synchronizing it back with Python. So now if I do slider.value in this kernel, you'll see that it's set to 58, and that's what currently is the value of the slider. And actually, if I set this value, so if I say this is, I don't know, 20, and run this cell, you'll see it actually synchronizes back to the front end. And so the SciPy widgets relationship with anywidget is simply that they compose very well to one another. They're built on a very similar foundation. And anywidget actually internally, the APIs that you define, like the Python interface, are shared with SciPy widgets. And so that's to make sure that you can use and reuse these different sliders and different components together with the custom widgets that you might build with anywidget.
Yeah, these are all Jupyter widgets. The underlying architecture is the same, but a lot of how the front-end code is managed is basically the difference. Where right now, traditionally it was very difficult to create custom widgets using the SciPy widgets framework. And so the standards introduced by anywidget make it much easier.
So the two should live in harmony together, but it's just like hopefully for making these custom widgets of your own, it becomes more approachable.
Take one last question in the back.
How does the underscore ESM transformation help?
Yeah, great question. So we will dive right into that in the first example, but that is the heart of like how you define the front end code for the module. So in the slide that I said before, so to repeat, the question was how does the in this notebook you'll notice in the custom chart that we made that there's this like underscore ESM field, and that is related to this that we were talking before, which is the standard piece of JavaScript that you write for the custom widgets that you might create. Oop. The ES module that you'll write yourself. And so what anywidget does is it makes sure that that gets delivered in the front end and executed, and where you define that is just on the class. Yeah. Yeah.
Do we want to take a couple minutes of break, or do we want to dive into a notebook? We'll take like a few minutes just so people can brush their water, coffee, any other questions, and then we'll dive right in to the first anywidget.
Cool.
Let's aim to be back by 8:52.
Yeah.
This wasn't a question.
Oh.
I felt it's like less.
Yeah, so
all the
yeah,
Venn
Widgets
diagram.
really is like the framework itself takes care of
Nice.
the
Like, I'm
synchronizing
guessing it's remote
the
control.
state, and like the custom messages sort of like you fire off a message and then you have to handle it somehow. So you could call the methods and
That kind of
sync
awesome.
or something like that, which could but it'd be fun to take a look at an example and try to brainstorm it.
Yeah, for sure. Yeah. I did get a verbal Vari. Do I like Boston? I can say like environment. No, because it's too hot and stuff. It's possible. There's too much pollen.
Yeah.
It's great. But when it comes to yeah, I'm from Vancouver. Yeah, as well. It's almost like spinning. I mean, we're very once I started going, I'm afraid to ask that. They don't even think about it, but it comes to it.
We were worried about this on Vari.
It's really fun out there.
We weren't sure about if how the
I asked them to install it for us.
okay.
It didn't work at first.
Yeah, okay. I was just like an uncertain thing where I'm like,
Yeah, so Barry has to install it.
Okay.
The beta installed it, but now the extension's installed.
okay. Maybe, yeah, if we're having an issue.
I'll go ahead and create a, because I created a local environment for it. I was going to create an environment with shared space just so it's there.
Yeah, okay. That'd be good.
Once it comes, people are going to use it, they can use people.
Thanks, John.
Oh.
Code
any
space,
key bindings?
my code space one doesn't have key bindings.
Okay, good.
So, um,
I think some of you might have gotten, if it kicks you off the code space, if it's idle for like half an hour, so we can move.
yeah, we'll be keeping active for the rest of the tutorial, so hopefully it shouldn't like idle out on everyone.
I know that it's cool, so I just want like very like introduction.
Well, you're together.
Yeah, we work together.
Okay.
Let's pull up the. I should just Google things on MDN every now and then. I'll put things on like MDN. I want to introduce a new web concept. And MDN was a yeah. All right, so let's all get started making your very first anywidget. Is everybody set up? Ready to go? Then please open the 02 Basics notebook. And you can all follow along. There's a really handy table of contents tab here that can help you if you get lost to reorient you on the right exercise. And yeah, so let's get started. So
we're going to introduce you so we only really need 2 imports for all these exercises. We need anywidget, and we need the traitlets library. And the traitlets library, as Trevor mentioned, is basically what allows you to synchronize state between the Python kernel and the front end. And so we'll run that. And we're going to do our little hello world. But we'll introduce you to the basic structure of an anywidget. You'll see that it's basically a class. You will subclass the anywidget.anywidget. And this class will define your widget. And the 2 things you'll see here, there's one property that's called _ESM. ESM stands for ECMAScript module. That's the JavaScript part. And in the simplest case, you can literally put in an inline string. And in these exercises, we'll be doing this. But this is really just sort of the prototyping phase. And we'll show you how you can hoist that out into independent source files very easily once you progress to something more advanced. You'll also, here's an example of just a few traitlets that you define. So some properties, they are typed. So they'll have type validation on the Python side. And then there's this extra thing called tag sync equals true that that tells the traitlet system to synchronize that with something on the front end model of the widget. And you'll see here that we have this boilerplate for the ECMAScript module where we define a single function in JavaScript called render. That is the most important of the life cycle methods that Trevor introduced. And this export syntax is basically part of the ES module standard. So this is a way to basically create a reusable module in modern JavaScript. There used to be many different modules, third-party module systems that made JavaScript packaging a nightmare. And that's basically how all the Jupyter front ends currently work. And this new standard that is now adopted by browsers is making it a lot easier. And so we'll start sort of talking a bit about, we're going to write a little hello world widget to start in exercise 1. And so the challenge here, if any of you have the just a little bit of web knowledge, you might know about the console log method in JavaScript that lets you log things to the console. The first thing you can do is, if you're on Windows or Linux, Control-Shift-J, or on a Mac, Command-Option-J. We'll pull out the developer tools for your web browser, which can I can't shrink it, but all right. You'll see over here we have the web console. I'm going to clear it for a moment. So, you know, if you do console.log hello, that's the print function in JavaScript, in your browser at least. And we're going to write a widget that's basically going to do this. So do our little hello world. And so that's exercise 1. So you have the boilerplate here for a simple hello world widget. We have the render function. And your task is to basically write, to log hello from any widget to the console. And then you can try that out. So I'll give you guys a minute or 2. And if you get stuck, you can then validate that by opening up your browser console and seeing that it works. So go for it. I just couldn't, yeah. Oh, it's there.
Yeah. Also, if the key bindings for finding the console are a little tricky, you can go up to View, or I might have to look up what it is. Developer tools. So View, Developer, and Developer tools, and that will just pop open this extra console where you can inspect what's happening.
On Chrome. Yeah. But they all, Firefox, it should be the same key bindings.
Command Option C on my Mac.
Ah,
For whatever reason.
okay. Okay.
Maybe a different browser.
Right, yeah.
Control-Shift-I in Windows.
Okay, there you go. Just developer tools. Yeah. Yeah, share it on Slack.
Yeah.
Yes.
It will be quite common when you are in developing widgets to have the console open because it's really like kind of the way that you can print things and just see if something's like running in the front end. So normally if you're like in this environment, you're in Jupyter, you can pop open the console and sort of start going from there.
anybody gets stuck, just raise your hand or put your sticker out in front of your laptop. But I guess this one will just, so again, we have a little cheat answer code at the bottom, but we can also just do this by hand. So it's basically just console log hello from any widget. With JavaScript, you tend to end things with semicolons. And there it is. So there's your very first any widget. So we basically were able to export a function to the browser and get it, at least the widget creation, to trigger that code on the front end. The next thing we're going to do is start creating and appending, manipulating what's called the document object model, or the DOM. This is a concept in the browser that if you think of your web page, every web page is basically rendered as a tree data structure that corresponds to all those HTML elements you think about. And so anytime you're in a browser, you can access and manipulate the DOM. That's basically how you make things appear on the screen and do things. And so we're going to use this. This is basically the DOM API in your browser. And if ever you are interested to learn about any of these functions, the Mozilla Developer Network, MDN, has basically like the authoritative documentation on all of the DOM methods and the web methods that are out there. And so very useful resource for you. Where are we? Yeah. And the simplest thing you can do is create an element, any of the elements that you may have heard of if you've ever played around with HTML. So P is a paragraph element. You can change its inner text. All elements have this property. You can then append that element. So that element is created but hasn't actually been put into the page. And so you can append it, say, to the body. That'll add the paragraph element to the top level body of your page. And so we can do this from within the render lifecycle method in your widget. And you can do that because the render method takes in up to 2 arguments that are named arguments. And one of them is, we call it EL for element. This is a JavaScript object that represents the output element of the cell that you just executed. So this is where you can start to inject content into that output cell. And so what we're going to do in this next exercise is, we say we printed something in the console. Now we're going to put something on the page in your output cell. And so we want to create an H1 header element. That's sort of like one of these header text elements. And we're going to write hello any widget. We're going to make the header element say hello any widget, and then you're going to append that to the output to the output element cell. And so when you render this widget, you should see a big header text that says hello any widget. So we'll give you another couple minutes to try this exercise out.
If we're working within VS Code, is there a path to looking at the console in VS Code? Yes. So the reason why we're doing it in the browser is just because it's easier to open. Right. And so VS Code you have to Command-Shift-P, and then you can type in toggle developer tools, and it will pop open the developer tools for VS Code. So VS Code is just kind of like a wrapper around a Chrome, so you can look and see what's going on.
The web is everywhere, even if you don't realize it.
Yeah.
Do you all ever recommend using access to the document itself? Like appending elements directly to it, or?
No. I would say, because you don't know the environment that the widget will be executed in, you want to really rely on the element
idea with the anywidgets, the render lifecycle hook, is that the platform that is like going to insert that widget somewhere provides, here's where that thing should be rendered. Inspecting like the global scope somehow to try to find what's on the page will probably tie you to like some platform like detail. Like there could be something like Jupyter Lab puts something in one place, and if someone tries to use that somewhere else, it like that piece of code may no longer work. But you can reliably think like this will be the output cell that will be passed into render like your widget.
Do you have access to the document in any environment or in most environments? I'm thinking
In most-
about VS Code.
Yeah, that's a good question. I mean, some things are just not available in some platforms. I assume document is universal, but the document variable, but you know, window is not necessarily universal, I think. Right?
In the front end it is.
The
Yes.
front end, yeah.
I think that you should have access to the document, but to use the document APIs for like creating elements and things like that. But accessing a query selector and things, it might be scoped to a particular like part of the tree that you might not actually have access to.
The point is that the lifecycle methods in anywidget are define a contract that these different new platforms, they could be web-based, but they don't have, you know, everything that, you know, the typical browser has. But at least if there's a contract where it provides you the specific front-end model of the widget and the element where you're supposed to append things, and you shouldn't be depending on global state. Yeah. I think somebody else had their hand up. Yeah.
I haven't read the table of contents, but I wonder if at some point you guys are going to do some comparison between like anywidget and say Jupyter widgets. Like what are the things that are
Yeah.
really good things about anywidget, and I would like to know like, oh, we can do this that you couldn't do with Jupyter widgets. Right. I don't know if you're going to cover that. It'll be great.
Yeah. I'm happy to, we can go through, like, we could show some slides maybe at lunchtime, like, or when we take, like, the break.
Yeah.
The thing that everyone should take away today is that anything you can do with any widget, you can basically do with custom Jupyter widgets, the traditional route. It's just that it standardizes, like, it makes it easier to actually author a reusable custom Jupyter widget.
And any widget created in Python like this is a Jupyter widget. And then there's sort of traditional SciPy widgets, and yeah, so comparing them is just, the only challenge is that you'd have to set up a whole developer tooling system just to do a traditional widget because it requires all the front-end tooling. So that's kind of why we can't compare them. We'd have to get you fully set up with a web developer's toolkit to get you going with the traditional way. So, but we can definitely contrast them, yeah.
Yeah, so widgets also you can export to HTML. So if you create like an output that maybe has some data in it, like the Altair widget or something, you can render that to HTML and like export that into a standalone web page. If that requires calling Python functions on some side, that will not work because you've sort of exported only to the browser, but you can use any widgets and custom Jupyter widgets just in standalone browser context as well.
Okay, so
Where should this H1 element be appearing?
it should appear in the output cell. So, so here's kind of the solution. One key thing to see, so there's a cheat sheet that we provided. If you look at the back in our index file, if you click here, this might be useful for you now and for the future. Just it helps you sort of compare Python syntax to basic JavaScript syntax. But the takeaway, sorry, the takeaway here is in JavaScript you declare variables with either const or let. It usually doesn't matter at all. Const just means that you intend this variable to be immutable. Let means that you intend to make it mutable. So that's why you see the const here. We're calling this variable h1. We're calling document create element. We're creating an h1 element. We are setting the inner HTML property or inner text, either would work, to hello any widget. And then we're appending this element using the append child method to L. And if you run this code, you're going to see hello anywidget appear in the output cell.
You did this in a code space and also do it on
So,
the
so this
computers.
why doesn't it also do
Yes.
console?
So right now, you're
Uh,
appended to the
is
document
it
body, which
you're
is
not calling console log?
like not currently visible on the
Okay, so it's CC where it goes.
Yeah.
So,
So here,
The console is like
so
a view of
in the render function,
no, it's really only if you, so we can also log to the console like this.
document.body.
And if I run that, and then I'll,
Sorry.
there we go, yeah. Yeah, sometimes there's a lot of noise. So you can clear it with this little button here.
Yeah, so one of the challenges of developing in the notebook environments is just that you're currently running in an application that could have, like Jupyter Lab might have a bug image or something. And so you'll sometimes get the console will have warnings and things that are coming from separate parts of the application that you're currently as part of, but you can filter, there are ways to filter the console messages and also clear the messages. So there's
Yeah.
this
So I'm
little
going to clear it now. The console can be very noisy, just warnings and stuff. The browser is very forgiving, unlike Python. You don't get runtime, like crapping out on you. All right, I think we'll move now just to the next section, which is so yeah, we made the browser do things, which is great. But can we actually get data from Python and transfer it over to the front end? So and so to do that, we're going to use traitlets. So we talked a bit about that. Traitlets is the tool that really helps you communicate state between the front end, between the kernel, some object that lives in the Python kernel, and then some model of that object that lives in the browser. And so we're going to do the same thing, but we are going to basically set these properties in the class using traitlets, and all the traitlets are typed. And you can set a default value. And then there's just this quirky syntax where in order to make it, I think traitlets was originally not developed specifically for this purpose. It's actually part of the IPython machinery. But then to make it something that actually is meant to synchronize with the web, you add this .tag method and you write sync equals true, and this makes it a traitlet that synchronizes with the state on the browser. And then any traitlet that you define in the class, you can set via keyword arguments in the constructor of the class. So so it'll take a default value, and when you want to create it with a specific value, you literally just pass in a keyword argument to the widget constructor. And as a traitlet, these are basically properties, so you can modify and get and set these values like a regular Python attribute, but they're more than a regular Python attribute. On the front end, you have access to the traitlets via what here is called the model object. So the model is the anywidget front end lifecycle methods expose these two objects, model and L, and the front end environment is basically responsible for providing these things, and model is in the Jupyter Notebook and Jupyter Lab and all of these environments, it basically corresponds to some front-end representation of your widget. And the model interface exposes, through anywidget, exposes only a few methods that let you interact with it. There's a get and a set. So if there's a traitlet in your model in Python, you can get the current value using just the get method and then pass in a string with the name of that traitlet. And we'll learn about the set one later. Yeah.
Question, because this seems to be like the point in which both Python and JavaScript seem to match.
Yeah.
And so we can only pass, let's say, very simple types like integers, floats. We cannot pass classes or anything like that.
So you can pass in through traitlets alone. You can pass in. I think you can even pass in, so there's actually a type map somewhere in the docs that maybe we can pull up, but there's a rich set of primitive types that have a corresponding JavaScript type, and Traitlets will automatically handle all the serialization for you. For more complex types that, you know, if it doesn't exist on the front end, like a Python, quirky Python class won't have an analog in JavaScript. So you really, in that case, need to provide some mapping between the two objects where you have to serialize that and then deserialize it on the front side. But in most cases, you know, for common sorts of data objects, we'll talk about that in a later, in the next notebook. If you want to send like an ND array or a data frame, like there are natural standards for doing that, and ways to sort of serialize data in pure binary, so it's actually very efficiently transferred. So you don't have to convert something to JSON and then deserialize it on the front end. You can actually send binary data directly between the front end and back end. Yeah.
Notice how function render here has a signature that is
Yes.
modeled on that L.
Yeah.
Previously it was
Yes. Yes.
this breaks my Python brain.
Exactly. Yeah. I was.
L, like,
Yeah.
this has positional arguments.
Yes.
You know,
Yes. It broke my brain too the first time I saw it. So this is so in JavaScript doesn't have the concept of keyword arguments natively. So in Python we were really like sort of spoiled that we can put in named arguments and stuff. So you'll notice something funny, like I have parens and then I have curly braces here. So this actually, if you look at it, it's like a deconstructed JavaScript object or dictionary kind of, or set, you know, and that's what's happening here. So really what is getting passed into render is like a dictionary, and you're deconstructing it into two keyword arguments. And so it doesn't matter, what matters is their name, not their order, and they can be missing. So you can pass in nothing, you can pass in just L, you can pass in model, and the runtime understands how to handle that. So that's a little JavaScript quirk. Yeah. Yes.
Kind of related to that, are those two words like hard-coded?
Yes.
I kind of call it model one.
No, you can't. So it's so you can think of them. So for your Python brain, these are keyword arguments, and you can put them. But you just have the flexibility to put them in the signature as you wish.
So strictly speaking, I could also reverse the order.
Yes.
Model, and that's fine.
That's fine. It's just a dictionary. You pass in a Quark's dictionary, basically, but it's, yeah.
You could rewrite the function to take in the object, like
Yeah.
as a single object, and
Yeah.
then access them by a dot in the function
Yeah.
body.
Maybe O and then O dot.
Yes.
Yeah, yeah.
Exactly. Do you want to maybe just do it to just
Yeah,
show?
sure. We can do it in this example, but yeah.
Sorry, would you mind doing it again?
Yeah. How's, is this okay? Yeah, okay. Maybe let me also switch the talk. Okay. So so in exercise 3, and then I'll demo the model stuff too. We're gonna create, so this is just the version that I showed you in the previous exercise. You guys need to modify this front-end code, the render method, and also add, the first thing you're gonna do is add a traitlet, which is a string called name. And on the front end, we want you to display the name. So say hello, and add the variable name, like render what the name currently is. And then when you create the widget, you can pass in any sort of name value that you like or use a default. And in the meantime, I could maybe go up and do let's call this. So for people who wanted to see, you could pass in your quarks here. I called it options. And down here, I'm saying options.l. And that should work. Yeah. us know if you get stuck or who managed to get it to work already. Okay, yeah. Oh, up here? Yeah, I just did it here to show. It's not super important, but yeah, if you're familiar with like quargs in Python, I could have written it this way, right? It's just you're passing in a dictionary. And then, well, in JavaScript, dictionaries, you can they're objects, and you can do that. But you can also, you can imagine deconstructing the object like this, and then you could write in model and L. Uh-oh, that's not good. May need to restart. Let's see if so my kernel exited. Let's restart it. Hopefully. Uh-oh. Did anybody else run into this? I might have to restart the code space. They did say the Jupyter Lab feature was in beta.
I've had some issues with the Jupyter Lab becoming a blank screen.
Yeah.
It keeps working in the VS Code. You open the VS Code.
Okay, that's fun. We can also do this in, does not look happy. Do this in VS Code.
Yes. Oh, we should touch on that maybe as a group quick. The F-string like interpolation.
Yes.
Like is kind of a interesting, weird thing in JavaScript. Okay.
Great. So we have, okay. Okay. Let me just check that it works. Okay. So we have a backup, luckily. Okay, so I'll start going through this. So the first thing we'll do is create a traitlet. Can everyone see this? Do I need to make this a bit smaller? Okay. So the first thing I did is I created a traitlet called name. It's a string. I set a default value, and then I set the tag sync equals true. Then here in the model, in the render function, we can fetch that name object. So I'll say model.get. Oops. And the next thing we'll do is use the JavaScript equivalent of a Python F string. So this is kind of newer syntax that makes it nice. JavaScript didn't used to have this. F strings in JavaScript use backticks. So I'm going to replace the quotation marks with double quotes with backticks. And then instead of anywidget, we're going to use the interpolation syntax. So it's a $sign followed by curly braces. And I'll pass in the name variable. I think that's it. Is that what we set to do? I think so. Yep. All right. So when I create this widget, what is it? It's not string. Oh, Unicode, yes. My bad. I set off one of your key bindings, Trevor.
Oh, right. Oh, you're in.
Yeah.
Okay. just do.
So it's actually called Unicode in Traitlets language, not string.
Sorry, we're. We should be able to reconnect.
Okay, cool. Let's go back to exercise 3 here. Okay. That was, okay. Okay, that should work this time. There we go. So it says hello world, but we can also now pass in name. Yeah, make it say hi to me. So now we have a variable that we can set on the Python side, send it to JavaScript, and it synchronizes, and we can print it out to the screen. Basic stuff, but that was just basically, so we've done the unidirectional communication from Python to the front end. The next step now is to kind of go full circle and get a two-way binding. And we're going to build that up incrementally with something a little bit more interactive than just text on the screen. We're going to build a button. We're going to create a button that you can click. We're going to count the clicks. And so, instead of creating an H1 element, we're going to create a button. So we're going to change the H1 into a button element. That's going to be the first step for this exercise. Then I want you to change the name traitlet that you just created and call it count. And then you can set the text of the button to be count as count. So it's almost the same thing. We're just, instead of an H1 element, we're going to change it into a button. So this is basically the last exercise. And so just modify from what we just had to basically render a button instead of H1. That'll be step 1. Okay. Did anybody get it working? Does anyone see a button? Yeah, you can't click on it yet? That's the next step. All right, cool. I'll quickly just show how this works. So literally, we just calling the variable button now, btn. We just created a button element instead of, right? It's just another HTML element. It's called button. We're setting the inner text property to, again, an interpolated string. Count is, and here we're interpolating model.get count. So we're pulling in the traitlet value, appending the button element to the output cell. And now our traitlet is no longer a string. We're going to count clicks. So be sure to change to integer, and we can set a default value to 0. So we're going to start at 0, and if we render this, we get a button. It's nice. It's count of 0. Doesn't do anything if we click it. That's the next step. Sorry?
Yes, the int default is 0. I
Yeah.
think several, and for
Yeah,
like the
string.
Unicode string, the default is just an
Empty string, yeah.
So a lot of the primitives just have sort of
Yeah,
a default built in.
right, right. And so the idea with JavaScript is it is an event-driven environment, at least in the browser. So there's this event loop that's always running. In Python, you have async. It's much more explicit, and not many people, it's more of an advanced use case thing. But in JavaScript, it's the norm, and it's there. It's always there. And the way you have to think about programming is there's all these user events that are coming in, and different parts of the page need to be listening for those events and reacting to them with callbacks. And so most of these HTML elements have basically a way to register callbacks. So the DOM method is called addEventListener. And there are all these named events that you can have that piece of the front end listen to, and then it will react by executing this callback function. And so in this example, you were literally adding if anybody clicks anywhere on the body of the page, it will log something to the console. That's this example. This syntax, if you aren't familiar with it, so JavaScript has several syntaxes for defining functions. This is one of the newer ones, but in Python language, this is just a lambda. So the braces here are where the function arguments go. It doesn't take any arguments. It takes this arrow. So these are called arrow functions because it uses this arrow syntax. And then in braces is the body of the function, what it does. And unlike Python, you're not restricted to one-liners, so you can write complete functions that return something. And you can have multiple statements in an arrow function. Okay, so then exercise 5, we're going to take what you just created, and we're going to have the button that you just created listen for when it gets clicked. And when it gets clicked, we're going to just do the most basic thing and just log it to the console. So that's exercise 5. So following sort of the example you see above, we want you to add a click event listener to the button, and then in the callback function, basically log to the console that the button's been clicked, and try that out. We'll give you a couple minutes for that. I'll start doing this just to basically show. Add event listener. So we're going to add an event listener to the button, to the click event. And we'll define an arrow function. And in that function, we're just going to log. Okay. I think that's all we asked to do. Yeah.
Yeah, so right now we're all prototyping everything just in the notebook because you can sort of see it in one place. You can move that code to a second file.
Yeah, we're going to show how everything is inline right now. So it's
Exactly. It would give you like sort of
yes. Yes. Yeah, so everything now we're doing is very inline in the strings. It's easy to make mistakes. There's no auto-completion. But this is really good for this simple tutorial because everything is in the same line of sight. But you'll see that you can export this into just a JavaScript file that you can edit in VS Code or even in the notebook. And you'll see some nice features that has. But you can just start with the inline text. And so, yes. So we just showed that the simple example of just adding an event listener for click. We log, and you can see down here, so the button's there. I click on it. Nothing's happening except down here in the console, it's actually printing. Console has a nice way of, if it sees the same thing multiple times, so you see a count here. There's actually a counter in the browser console itself. So it printed 7 times, 8, 9, 10. Okay, so that's nice. So now the next step is, okay, let's, so we've updated, we're clicking on the button. Now we want to actually update that state and be able to read it from Python. So that, we want to know how many times that button has been clicked, and we want to be able to pull that out in the kernel. And so to do that, we use the other method in the model object, which is set. So we talked about get to get the value of a traitlet, but we can also set a traitlet from the web. And it's pretty simple, as you see. It's just model.set, the string name of the traitlet, and then a value. And there is an extra little step that to actually propagate this, you have to then call model.saveChanges. In principle, the idea here is you could efficiently set multiple things and then synchronize them all at once instead of synchronizing each one after another. But it's just sort of part of it. This is sort of the widgets API from the front end. So it's 2 steps. If you set a traitlet, just remember to save the changes when you're done. And so in this exercise, when you get the count, so we're going to get the count and increment it, and then save those changes to Python to sync with the model. So let me close this. When you're done, we should be able to click the button in the front end and see the widget count change when we run the notebook cell. So when we run this in another cell, we should be able to see the number of times the button was clicked. So I'll give you a minute for that. Anyone manage to get it working? Yeah, awesome. Yeah, you're not going to see the text update right on the screen, but you should be able to see it, the state in Python change. So when you evaluate this next cell, widget.count, you should see the number of times that you clicked. And so just to kind of summarize this, the render function is called render because when the widgets finally render to the screen, this is what's going to execute. And so the first time we do that, it's going to create a button element. It's going to insert this text and insert what the current count value is. Then we have an event listener that we've attached to the button. And what the exercise is asking us to do is every time it does get clicked, let's increment the count value state property. And that's all we're asking to do, which means that it should update on the Python side. So to do that, all you have to do is type in, again, our model object. Now we're going to set. Actually, I'll split this into two statements for clarity. So I'll do model.get count. So let's get the value. And then I'll set the count value to count plus 1. And then I'll make sure to save the changes. Right. So let's try that out. All right, we see our button. I'm clicking on it. It says count is 0, but if we actually evaluate widget.count, I actually clicked it 12 times. Okay. We'll give everyone a minute to kind of catch up on that. And then the last step is let's close the loop and actually see it on the button. All right. So again, to close the loop, we'd like to actually see the button update. It's what it's printing out, right? So at this point, we need to. Okay. We have actually. This isn't an exercise. You can go and run this. So we've now taken our button. We've added an event listener for click. We take, const new count. In this case, we take the current value of count, add 1. So that's the new value. We are setting the inner text of the button now. So this is the change. So not just updating the model state, but also updating the front end element. So now it should print out the current count number for the button. And we've set count to the new value and save the changes. So we can try this out. Okay, let's try it out. Yay, it works. But there's a bug. Does anybody know what it is? It's kind of subtle. So let's confirm that this also works. So if I go to widget.count, it's 11. Looks good. But remember that traitlets are full-blown properties, so we can get the values, we can set them too. So what happens if I do this? You might expect that the button will update, but it doesn't. So we've missed something in the loop. There's one little step. So we've added event listeners to elements in the front end, but we also need to listen for changes in the model on the front end so that it can also, so the front end can actually react to changes that are happening in the Python kernel. So now you really can talk both ways. You can click on a button in the browser, it should update the state, but you should also be able to manipulate properties in the Python object and have the front end react to that too. So that's our last exercise here is to use, it's basically the same idea as having an event listener, but this is an event listener defined on the model object, not on an HTML element, and so it has its own API. So this is the API, we've seen get and set, and this is model.on, and it's the same idea. So it's an event listener. These have specific names. It's part of sort of the Jupyter Widgets system. And so there's an event called change, followed by a colon, and then the name of the traitlet. So this is going to listen for changes in the my value, in this case, traitlet. We put in a callback function. And then in here we can grab the current value that it was changed to and do something with it. And so the idea here is you treat this model object that lives in the front end, it should be your source of truth, regardless of whether the value is changed on the Python side or on the JavaScript side. And so if you keep that in mind, it's easy to think about how to program these widgets. So the model really is your reference point. And so to fix this bug and really finally close the loop, this is exercise 7. So we have this example that doesn't have that doesn't currently listen to changes from the Python kernel when you update the count. And your task is to use model.on to add that final event listener to listen to changes for count and update the display. So we'll give you a couple minutes for this one. There's a little subtlety to this one, but we'll show you basically what we said. That what we need to do is have the model register a listener on the model to listen for change to the count traitlet. And we're gonna put in a callback function. And when the count changes, we're going to set the inner text. Actually, what I'm going to do, well, I'll actually grab this code here. So we want to get the current count that we received when the count was incremented, and then set the inner text of the button to say count equals new count. Now, we mentioned that if you really treat the model as your source of truth, we don't need to duplicate this code here. So I can remove this. Sorry, this is what I meant to do. So let me just, for simplicity, write it that way. So now you can see when we click the button, rather than performing all of the edits to the DOM itself, we already have the model listening for any change to count, whether it's coming from the kernel or the front end. So the button listener itself, when you click, all it needs to do is update the count traitlet from the front end. And that will also trigger this callback. So right now, your model callback for changes in count is the one responsible for knowing, oh, the count variable changed. Doesn't care whether it came from clicking the button or from updating it in the notebook. It will grab whatever the current value is that was just updated and reset the text of the button. Yeah.
How do we know what the model object API is in your documentation?
Yes.
Yeah, it's in the anywidget files.
Yeah.
Pointing to it.
So it's essentially a stripped down version of the model object that is part of SciPy widgets and Jupyter widgets, which has a larger surface area. This is actually just restricted to the core things you need to communicate between DOM. So there's basically get and set for this shared state. And then we'll also learn about sending and receiving custom messages. And then finally this on thing. That's basically the API. Okay. So we should see this increment. Looks good. Now I'm going to reset. Sorry, yeah.
Just a quick question. This bidirectional communication, maybe you mentioned it before, but is through WebSockets?
Yes, all of it is ultimately happening through WebSockets. Yeah, so there is an underlying Jupyter widget protocol that works across the Jupyter COM. It's all WebSockets based. That's why that's actually very efficient. So instead of writing a traditional sort of server client like architecture, you have this bidirectional communication thanks to WebSockets. Yeah, at the very bottom. And okay, moment of truth. I reset count to 42. Boom. Okay, there we go. Great. So now we can really send state back and forth and update the UI. I'll wait for everyone to get that done, and then the last little thing we'll just sort of look at together. It's about we can add styles. So just like there was an underscore ESM, we also have an underscore CSS, and you can learn about all the wonderful world of CSS, but you can start styling your button any way you like. So, but I'll give everyone like 30 more seconds to sort of just try out this example and make sure it works. So we have this really simple example here, just called styled widget. It's the same widget that we just created, but we're adding a underscore CSS property, which just like the ESM can be hoisted into a separate file, but you can play with it in line just to start testing things out. And if you're not super familiar with CSS syntax, don't worry too much about it, but essentially anything that you class, you can actually see in JavaScript, the native way to do this. If you want to, if you've ever learned about HTML, you can add a class to any element, and that lets you style it in a specific way. So you give it a named class. You can do that from within JavaScript with this class list, which is literally a list, like a Python list, an array of classes. So you can add a name to, in this case, the output element, and then we can define styles down here. So within the styled widget element that has a button in it, we can set all these properties. We can set a property for when you hover over the button to change the color. And so if we just execute that, you can see that count is pretty. It gets a bit darker when I hover on it, and it just works the same way as before. The last thing we want to show before we take a break is just that the power of ES modules being a proper import system is you can really now bring in all kinds of interesting JavaScript libraries that you might want to try out in a notebook. So anything from if you want to start playing with D3, it's trivial to now write the anywidget front-end module that basically brings this in and applies some API from a third-party library that you really want to try out. So you have a question? You can add IDs, yeah. It's a different method, but all of this stuff is available via the DOM API. We're going to do just a very quick example with a fun little library called Confetti. And what's really cool about in JavaScript, you can import directly from a URL. So these are ES modules, esm.sh, and there's this canvas confetti. And that's pretty cool. So you don't have to download and install a module. You can literally pull it directly from a URL. So I'm quickly just going to pop to the answer here, where we have import confetti at the top. And the confetti API is literally just a confetti function. So we've imported the confetti function. And it's fun because you can set an angle. It has an angle parameter. And so we're going to use, it's in degrees, and it's periodic. So you can pass in any value, and it'll do mod 360. So we're going to actually use our count button to parameterize where the confetti shoots out. And so let's give that a try. So here's our button. So we've put in the little confetti whenever there's a model on change. So anytime the count traitlet changes, we're going to fire off a little confetti. Yay. So we just want to, in the interest of time, we just wanted to show that one off, and you can play with it. And the last little thing, as we said before, is any widgets are Jupyter widgets, and they compose with existing any other Jupyter widget, including the SciPy widgets library. And there's some useful user controls that you can pull directly from it. So in this case, we have SciPy widgets. We're going to create our confetti widget button that was defined just above here. And we're also going to create a slider in another cell. And we're going to use a function called SciPyWidgets.link that allows us to link two different widgets via their traitlets. So we're going to link the count traitlet in our button to the value traitlet of the slider. So if I just execute this, I now can fire off confetti. You'll actually see that the slider's changing too. And I can start dragging the slider around. So you really now, very easily can compose, UI controls, custom visualizations, custom web APIs with your own sort of Python objects. That's sort of the power here. So I know that this is a very toy example, but this is just to get your feet wet and just to overcome any fear you might have of coding just a little JavaScript. And with that, let's take a short break, and we'll come back, and we're going to do another fun one that does a few more advanced features. We're going to create a little Mario widget. We're going to play with a few more web APIs. but just show you sort of a few more features that we can do with iPy, with anywidget. So is now like the official break? I don't know how long it is. Yeah, okay. So let's meet at 10:20. Thanks, everyone.
That
Okay, it came up, a couple people asked this, like, is there a nice like cheat sheet around some of the things that we've been learning today? And we don't have like a explicit cheat sheet. I think it's a great idea, probably something for a sprint this week. But there are kind of two like little tips that I want to share at a high level. Anytime that I personally like want to make a new widget, I copy and paste this example like all the time. So I go to the docs, just copy and paste this into a notebook, and that's usually my starting point because it sort of does some of the plumbing. So just a tip, like you don't have to remember a lot of the syntax, just go to the documentation site or the GitHub README, copy and paste, and that can be like your starting spot.
Another fun Easter egg. Click on it.
Oh yeah, this is a widget that's embedded in here.
It works, because all that is front-end state, doesn't need to talk.
Yeah. The other thing is that we have a section of our documentation. So this is sort of with dealing with contrasting like traditional Jupyter widgets and anywidget. The traditional Jupyter widgets has this documentation section which is called building a custom widget. And this section in our documentation that's called Jupyter Widgets, the good part, is trying to distill the essential pieces from that documentation into anywidget things. So one challenge is that with just building custom JavaScript applications is that there's usually a lot of JavaScript tooling that gets involved. And one piece of trying to get like the essentials for Jupyter widgets out of this particular documentation is that it mixes some of those like build processes that you don't have to worry about with anywidget with some of these like essential concepts like sending data and updating and getting data. So we try to distill it down here in a way that like compares and contrasts the two. So if you're familiar with Jupyter widgets, it sort of gives you a side-by-side comparison of how we view some of the different steps. But if you're just coming to anywidget for the first time, I would just skip down to the section talking about connecting between JavaScript and Python and learning about traitlets and something that we're about to talk about next, which is sending custom messages. The last thing I wanted to point out here is that we also have this Nazar mentioned earlier, and it was asked, like, how do you, if I have a custom class, how do I send that to the front end? The documentation has a mapping of like Python primitives that are automatic and how they're mapped to things in the front end. So like a string maps to a JavaScript string. JavaScript doesn't have a notion of integers, so either float or int become just a number in JavaScript. So just these kind of things to think about on the front end. And the last thing I want to point out is if you do have a custom class, we do have a section on, it's called custom serialization. So we're not going to cover this today, but if you want to do something custom, I have a class, I want to serialize it in a way that then I can load it on the front end. Read here. It shows how to take a file path and convert it to the contents of the file for the front end. So your user could pass in a file, and then on the front end, you just get like the text contents of it. OK. So like Nazar mentioned, we have sort of it's a fun example. Like I think that we've just covered these building blocks, which are getting something in the output on it for a particular cell, and then being able to communicate back and forth with that from Python. And so in this notebook, we'll take some fun code that I actually found from this tweet. So this is the creator of D3. He's pretty well known in the web community. It just has this like super terse tweet with like this JavaScript code. And the first thing I noticed is that it uses this like audio context API. And so one kind of cool thing about the browser is that it has all these built-in APIs that you can expose to Python if you're using them in widgets. So without this, there's no dependencies here. This is just built into the browser. And if I take this piece of code and I open up my, my console here, I can just paste it in. If I run it, it has this like fun kind of silly like Mario chime. And when I came across this, I was thinking about like what would be a good example. So we're gonna know if everyone's on pace, like with the tutorial today. But I thought it'd be fun to like take this little piece of JavaScript functionality, which is kind of like this silly chime, and think about like really the process of how do we expose that to a Python API that feels like very natural to use on the Python side. And so we're going to cover many of the things that we just talked about in the previous section, but also some newer concepts from anywidget, which are sending custom messages. So far we've only talked about traitlets. We're going to talk about sending custom messages, which are sort of like these one-way just message channels between each of the worlds. We're also going to talk about sending binary data, which from some discussion in the break just now, I think is something that a lot of people would be quite interested in, and it's super important, and I think like one of the coolest aspects about what people are now actually building with anywidget is based around its support for binary data. And then we're going to briefly, someone mentioned earlier, I hate writing these like inline strings. Can I do something else? We're going to talk about organizing a project and just like where we'd move files and working on separate files rather than sort of these inline strings. So I showed this tweet from before. This is that piece of JavaScript. And while I wouldn't generally recommend just copying and pasting code the same way you probably shouldn't do it in your terminal, it got the best of me, and I've done it for you now, so it's it's just this this usage of this audio context API. And in this notebook, I've taken that bit of code and just sort of fixed it up in a way that you can kind of see what's going on. So rather than it being this sort of really terse piece of JavaScript, I've written this function for you that's called chime, which is just sort of reformatting of that usage of that API. And it's not important that you understand like how this API works. If you do want to learn about that, I'd recommend reading about the web APIs in the MDM documentation. But we're going to like try to think about taking this function and plugging it into a widget. So it's sort of like this idea of we have this library or this functionality, and we want to put it into the notebook environment. So let's start there. So in the very first part of this example, I want to start with taking this JavaScript function and just getting it into the ESM of the widget. So in the last section, we like built a widget where we define these custom counter and like a hello world. And in this example, I just want, in the first exercise, I want you to make a custom widget that, as a part of its render function, calls the chime. So when you execute the exercise 1 cell, you should hear the chime sound. And since we do have a few people, like if your audio is quite loud, we probably like should keep it at some volume. But please feel free to keep your volume on, because I think it will be fun for others. All right. Okay, so while people are getting that working, I'll implement sort of the example. So we're going to create our inline string. We're going to define a function that's called render. It's going to get in our model and our element. Although for this, we don't really need access to either of those, but I'm going to export default render, render. And then within this function body, I'm just going to invoke the chime function. So I'm going to go up here, copy and paste this bit of code. And we can just define another function in our JavaScript module, which is called chime. And now when I run this cell, oops, did I get in? Oh, I haven't imported. I've done. We sort of have the initial example. So, right, so far, in order to trigger this chime sound, we're just triggering it anytime we display the widget. So an important thing to note is that render only ever gets called if we display, or that is the last element that's in the output. So if I assign this to a variable, for example, and run this cell, render does not get called. But if I return, or the last element here is the widget, or if I, in the notebook, use the IPython display for this widget, it will also call that function. So it's just important to remember, like, render only gets called when you try to display like the actual object that you're creating.
You guys like think about a Python wrapper, like every object is a wrapper, like a widget that's just an enhanced wrapper.
Exactly, yes. And in fact, in Jupyter, there's like a special dunder method that you implement on your class, which gives it these superpowers. So you just say like, hey, Jupyter, like I can render myself as a widget, and it decides to do that instead of using the text repr. Okay, so next we're going to, so right now, like I mentioned, we have this button, we have this output that anytime we run the cell, we hear the chime. But it'd be cool, like the only way we can do that is by re-executing the cell. So we can take what we learned in the first section and actually create a button, and then in that event listener for that button, so the action that we have to actually, when we click the button, we can call our chime function. So for exercise 2, we're just going to take the example from exercise 1, or the solution from exercise 1, and we can copy it down here. And then within this function, we're going to take some time where you can create a button element, set the button's text to "It's me, Mario," and then when you set an event listener using the API we learned in the last section, so that when you click that button, you call the chime function. Okay, so I will, as folks are getting that, I'll just start coding up the example. So we have the answer from exercise 1. I'm going to create a button, so const button. I think in the answer we call it abbreviated, document create element, button. Oops. Then I'm going to set the button's text, so inner text to it's me, Mario. It's a me. And then we're going to add an event listener. So we're going to say button.add event listener for that click event. And then we're going to create a function that gets called anytime that click happens. So we can move our chime that we had when we called anytime that the render function was called. We can move it out and put it inside that function body. And now we're going to invoke the chime function anytime we click the button. And the last thing to remember is that we need to append our button to the DOM. So we're going to do l.append child button. And now if I render this cell, oops, see I'm not displaying the widget. If I run the cell and display the widget, we should see the button. And now if I've done everything correctly, when I click the button, there's a chime sound that comes out. So right now, we just have sort of hard-coded what this function does. We've just copied and rendered the hard-coded values that are in the function. And in this next part of the tutorial, we're going to take what we learned in the first part about using traitlets to parameterize this function. So we can take pieces of the function that have that we can set as arguments. We can lift pieces of hard-coded values from that function, which call these audio context API, and set them as arguments. And then we can bind those arguments as traits, which then means that anytime we click the button, we can use whatever the current value is set from the Python side. And so what it lets us do is we can sort of expose this function in a parameterized way to the Python side. So I've taken the liberty of extracting out a couple of properties from this original hard-coded function, which I've annotated here with these new annotations. And again, it's not you can kind of treat this function as like a black box. If you're curious, like that's why it's here, and we're going to copy and paste it into the code. But specifically, we've set a property for the duration, and the tone that you hear, or the chime that you hear, is a composition of 2 tones. So it's like da-da. The first tone is called tone 1, and then tone 2 is the second tone, and this is the frequency.
We're using that deconstructed object notation.
Right, so when we call, what you'll see is that when we call chime in our function, we're going to have to pass in something that is an object. So it's not going to be passing in separate arguments to the function. We pass in one argument to the function that's a JavaScript object with these keys. So to get you started in exercise 3, I've taken the liberty of copying that function down. So here's what is just above in the cell. But I've left these, the invocation of that function to be hard-coded inside the event handler. So you can see like the duration is still 1, the tone 1 is still this integer 988, and tone 2 is hard-coded. And your task in exercise 3 is to extract those parameters as traits. So we want you to add traits onto your widget model and then access the current value of those traits within the event callback. Oh yeah, the chime I believe is in seconds, so.
There we go.
Okay, so in this callback, I'm going to start adjusting these one by one. And I do think, like, I want to type this out slowly just because I think that this kind of taking pieces of state and lifting it out is really like the bread and butter of creating like a custom Jupyter widget and a custom anywidget, is that you sort of see these pieces of state that you want to share. You identify where you actually use that piece of state, and then you lift it up as something that is set on the model between Python and JavaScript. So we'll go and do this one by one. So duration, I'm going to go down and set a new traitlet that I call duration. It's going to be a traitlet, and it's going to be an integer. And I want to set the default value to 1.0, or let's do a float, sorry, a float. And we're going to do tag sync. So with just this line of code, I've defined that sort of like shared piece of state between the front end and the kernel, but I haven't accessed it now in the code that I had in the front end. So I'm going to take the duration that I have in this callback, and I'm going to do model.get duration. So I'm just simply taking that value, setting it as a default parameter for a traitlet, and then accessing that traitlet here. And I can do the same for tone. So I'm just going to copy what I have here for both the tones. We'll call this tone 1 and tone 2. These can be ints. And I'll set them each to their respective default values as well. I'll do tone 1, tone 2. Okay. So now if I run this widget, it's the same widget, as before. Oh. Am I missing something? Let's open the model is not defined. So this is what Eric spotted earlier. So I did not pass model even into the function this time, but I tried to access model. So I'm getting a reference error, which is JavaScript saying, like, I have no idea what this variable is. You haven't declared it. So in the render function, I'm going to add model. And it's just pulling it out of that key dictionary-like thing that we're getting back on the front end. So now if I run the cell and I click, I have mine from before. But then I can run these cells below, which will change on the model, both on the front end and the Python side, what the current values are for the duration and both the tones. And now when I click the button, I've changed like sort of that tone because I've adjusted those properties from the Python side. So in the next section, we're going to learn about a new way to send data or send information from either the Python side or the JavaScript side in sort of a non-synchronized way. So it's just, I can emit a message where I say, hey, Python, do something, and I can listen for those messages on the front-end side. And so this can be useful for types of actions that don't necessarily reflect like a shared piece of state, but are just more like signaling to one of the environments, like do some action or emitting some event. So the idea is that like right now when we click that button, we physically have to like use the UI to click the button. But with using this custom send event or this sending these custom messages, we can implement a method on our class, which is called click, which is programmatically clicks the button. So what that lets us do is rather than only allowing us to trigger the noise from a manual click in the UI, we can have a function or any sort of Python thing call our widget and do some sort of update to it. So to achieve this, we're going to use the anywidget.send API. And send is another API that is on the model. So far we've learned get, set, save changes. And this API is called send, which allows us to send any type of custom data between the browser and the Python side. And similarly, you can send the data from the Python side to the front end. So on the Python side, we can emit messages by calling anywidget.send. So on our class, the simplest way to illustrate how this works, I'm just going to show this at a high level, going through the example, and then we'll implement our click method based off of this like API usage. So the most simple example of a widget using send is, this is sort of follows a trend that you probably have noticed today, is that we're just going to we just want to log something to the browser console. And the idea is that of this example here is that we're going to create a class that we call console, that then we can call console.log on and actually send messages to the browser console. So that it's sort of like an inception here of like, we have this Python thing that we're calling console.log, but it's calling the JavaScript side. And it's just sort of a silly way of just showing that we can invoke sort of this JavaScript API in a one-way manner from the Python side. So the way that you listen for these messages on the front end is using that model.on method that we learned before for listening for changes, except there's this custom message that's called, and this is a convention that comes from SciPy widgets, but it's called MSG, so for message : custom. And so you can register a callback or this function that gets called any time that render is called. Or sorry, any time that a custom message is sent. So we create our class. We add this event listener the same way that we add a change. And now we can display our console. So we haven't put anything on the screen, so that's why there's nothing that's displaying there. Like we haven't appended anything to the DOM, but I'll open up the browser now. And if I scroll down and I call send, which is coming from anywidget, the anywidget base class, I can send a piece of data that's JSON serializable to the front end. Send also supports sending binary data as a second argument. So if I wanted to send a list of, you send binary data as a list of binary buffers. So if I wanted to send binary data, that would be the second argument here, but it's optional. So if I call send, let me increase the size of my terminal, or the console. When I call send, we should see hello gets logged to the console in the front end. And we can send kind of anything. So anything that's JSON serializable, so like a dictionary, we can send that to the front end as well. So if I call console.send foo : bar, so Python dict with the key foo value bar, and send, you'll see that in the front end we get that object back. So we sort of have sent this message and we're receiving it on the front end. Yes? So I'll get, we haven't received the message yet in the front end, or it's in the example here, haven't inspected it yet. But that is a new syntax feature in JavaScript that allows you to sort of check if a key exists and fall back if it doesn't. So if you were to chain those without the question mark, you could get an error because you sort of, It's a language feature that is recent, but I'll cover that when we get to the example. Okay. So we're calling send directly here, which is sort of like a lower level SciPy widgets API. And the API that we want on this class is something called log. So I want to be able to say console.log and actually call console.log in the front end. And so on our console class from before, we can add a new method that's called log. So let me try to clear up some of my space. So I have my ESM that receives a message. So I'm getting the message, I'm calling the callback, and what's different from the change event from before is that the first argument now for this function is populated, and the value of that is whatever was sent from the Python side. And then we can inspect that value within this, within the function that we're implementing. And so what was just pointed out is that there is this question mark that is here, which allows us to treat this sort of as a, it's a language syntax feature in JavaScript that allows us to just check for a field if it exists. You could think of it sort of as in Python, you can do get with none, and if it doesn't return anything, it's like a safer way than trying to access, or you sort of opt out of Python's strictness of accessing a key if it doesn't exist. And that's similar here with JavaScript.
Basically, MSG is a user-defined dictionary, if you think about it, in Python language. It's translated into an object in JavaScript. And then the message question mark dot kind is like doing, in Python, it'd be like message.get, where if it doesn't have the key, there's a default, like null, instead of a key error. That's all. That's the syntax.
Yep.
And the other quirky thing, if you're not familiar with JavaScript, you might notice that there's 3 equal signs.
And this is an artifact of having a language that is stuck in the web browser. So it was, I believe it was a, they thought it would be nice to have type coercion in JavaScript. So you could say the string 0 equals the number 0, and it would automatically, or double equals will coerce one of the types to be the other. And strict equals was added later to say, no, we actually want strictness. So it's an append-only language, so we can't really like remove many things.
Double equals is broken.
Yes, so use triple equals if you're checking for equality. And so in our log method, we're just going to send this dictionary with a key called kind and a message. And then the data property of that is going to be the custom message that we're sending. So we could just send the message directly and not do any of this check on the front end. But what this kind of does is we create our own sort of message dispatch system where we are creating messages with a type, and then we can inspect that on the front end and figure out how to handle them. So now I can run this piece of code, and in this cell below, I have, I'm calling console.log in Python, which then in the front end says woohoo in the front end. So this was just an example to try to illustrate, like, you use send to emit messages to the front end, but you don't have any of these guarantees around like synchronization of state. It's really to just send messages in one direction. And for this action of trying to click our button, we really want to use this send API. So in the next exercise, in example 4, let's try to take what we just learned about using send to implement a click method on our widget. So we have our chime that anytime we click the button, it makes the chime, and we have these traitlets from before. And in this block of code, you have a to-do to implement this click method. And the hint is that within this, you want to call self.send and send some data to the front end that clicks the button. The other hint is that elements in the front end, in your DOM, have a programmatic method to call click on them as well. So you can call element.click as a method, and that will will trigger the same type of event as if I were to click the button manually. Okay, so I will start coding taking the example that we had before and implementing the send API. So let's just make sure this is working. I have this button. When I click it, it makes the chiming noise. And what I'll start by doing is implementing send within this function body. So within this method, I reference self, which is where the send method exists on the Python side. We use self.send. And following this convention, we can emit a kind. And the kind is just going to be click. And we don't need to send any other data with that. So anytime we click or we call this method from the Python side, we now need to add a listener to the front end that is listening for these custom messages and chooses what to do with it.
That we define this ourselves. This is sort of a user-defined protocol.
Yep.
So we're setting kind as a key on this message custom.
Yep. So now I'm going to add a single message handler on the front end, which is message custom. And then I'm going to, in the function body, which fires anytime we get that message, I'm going to extract the message, which is what we're getting from the Python side. And I'm going to say if message, using that safe syntax .kind triple equals click, we can call button.click. So remember, we have a reference to this DOM element from the variable above, and we can just call it below and invoke the clicking action. So now, if I run this, I can click the button, but also if I run the cell that calls our Python button, or Python method click, it'll also call the method again. And so it's kind of cool because we could actually write a for loop, right? So we could do something like for I in range, and maybe I should import sleep. Or is it time? Okay, so for in range, I don't know, 4, we can do time.sleep 1, or is it in seconds? It's in seconds. So we can wait 1 second, then we can call widget.click. And so now we're going to fire this function, or fire this cell, and it's going to sleep and call our method for us. So if we run. I think it would probably fire a bunch. I think it fires so we could do it very quickly, but I think all the messages get sent. It just happens so quickly that you kind of hear you can't actually separate them quite easily. But if we did something like, I don't know, 0.2, you can kind of get crazy with it. But the idea is just to point out here that now because we've exposed this sort of action event that we've defined for a user interaction, we can also call that from Python. And now you can think about, maybe I want to write a method that at some point calls this front end thing that I've set up. And really that's kind of what we're trying to teach here, is that you can expose this piece of functionality through a Python API, and now you can use it the same way you would any other Python function. Okay.
Users can interact with the front end, also programmatic agents then.
Okay, so,
Yeah, quick question. So before you use kind message, and now you use kind click, so is that basically still flexible? We can just do whatever we want there?
we could send something here where we just say blah. You can send anything you want. It's kind of a convention to create an object that allows you, so imagine I had a separate method. I'm trying to think of something else I could do here.
It gives you your own custom namespace to have different custom messages you can send. You have to handle them independently, so you need to check.
Okay, so because I did kind message and then data click, and then I listened for click instead. Okay.
Yeah, they have to match.
Yeah. Okay.
Yeah, exactly. You can send anything that you want. It's just if it lends itself to allow for, because the thing is you only ever register one handler for that custom message. So any type of message that you send, you need to handle in that message body.
Okay, yeah.
And so it allows you to sort of it's sort of in Python you can have a match statement, or sort of you could sort of key on one of the properties and then figure out what to do with
You
it.
listen one time, and then you have to parse it out.
Exactly.
Yeah,
Yep.
the system is only one event handler for all custom messages, so you have to write your own dispatch system.
That's the part that I was missing.
Yep.
Thank you very much.
Mhm. Cool. So as many of you noticed, we're now getting this big wall of red text, and it's like kind of getting not so nice to work with. And so at this stage, we're sort of moving a little bit beyond a prototype. And with anywidget, you can start gradually transitioning these inline strings into separate files. And so in this next section, we're just going to take that code that we had before. So I'm going to take this ECMAScript module that we've written, and then in my file system, I'm going to create a file called index.js, which is just sort of a convention. I think I already had one. Oops, I have to wait for the, can I add text file? Okay. I'm going to paste in that code here. Yeah, I think when I hit save, it'll be fine. How do I go on? There we go. I hit save. I'm going to call this index.js. And once that file has, what's going on here? Maybe this is a code spaces thing. Okay, I'll just use this file. So now in Jupyter Lab, I have my, oops, let me get rid of this, discard. I'm going to go back to the SciPy Mario notebook. And in a separate tab, I'm going to open up my index.js. And so this allows you to sort of have the side-by-side. You could also do this in VS Code, but you can have your side-by-side view of the JavaScript code that you're writing here on the right, and the Python code that you're working with on the left in the notebook. So I'll go down. Let me find the section we were in. Exercise 5. And because I've copied this file over, now instead of passing in the actual text of the file for ESM, I'm going to give the path to the file that the JavaScript code now lives in. And so if I run this cell, we have the same exact thing as before. It's just we've moved that code from the inline string into a separate file. And you can see that this is now like nicely syntax highlighted. And if I was in an editor like that had language information like VS Code, I would get more hover information about like what methods are available and things I could call. So especially if you're trying to learn the front-end APIs, it can be nice to play around with the JavaScript in an editor like VS Code.
And is there some magic that it knows that that's a file? Before we had a multi-line string, so now it's an inline string. And there's some magic going on to the inline string. It's a file. And
that's something that we've considered changing to make it explicit that you have to pass in a pathlib path for the an object rather than a string. Currently, the preferred way probably would be to use a pathlib path. But we do some inspection to see the export statements because that is what defines the ECMAScript module or the export default tech. But if you pass in a pathlib path, we will not try to do any of that guessing. Yep. Yeah. Yeah. Okay. So this is just to show that this is much nicer, and just that. And now we can also take a moment to just pause. AnyWidget has a system built into it also, which allows you to work on your JavaScript files without having to rerun and execute cells in the front end. And this is something that. Okay, so we call this hot module replacement, or HMR, and what that means is that in development mode, AnyWidget can start listening for changes to the files that it depends on. And because we have this shared representation of state, we can freely replace and recall the render function when you save or make changes to that file. Now, this behavior is opt-in because we don't want to trigger this in environments where like listening for file changes in like such as a production environment. And so what it requires is that in your notebook, we add, you can set an environment variable. So we can say env anywidget HMR equals 1. And if we run that, we have now set the environment variable in the notebook. And if we run this cell, it says it's me, Mario. But now if I change this to be it's me, Mario, with a bunch of exclamation points, and I save, you'll see that it automatically has changed the text in the front end. And I didn't have to change that cell. And the nice thing about that is that one thing that can often happen is we actually get our widget to a particular state that if we need to rerun the cell, we'd like lose that piece of that state that is whatever we set it to. So for example, I have this instance of the widget. Let me try to create a new cell. And let's say I set the widget, widget.tone to equals, I don't know, 600. And I save that. Oh. And now if I hit, you'll hear it, the sound has changed. But now let's say I wanted to change something with the button, like I wanted to change this to lowercase Mario now because it's quiet, and maybe just a trailing ellipse. Now if I were to have to do this in the normal cell, I'd have to rerun the cell and rerun that piece to get the state to where I was. But now if I just save the JavaScript file, it's changed, but the state has stayed the same. And so that means is that you can really, especially with adjusting styles, you can very nicely like start to like tweak these things without having to like get back the state of your widget. And that can be convenient when doing some of the more tedious like front end things. There's this environment flag that's called anywidget HMR, and it's just to make it explicit to opt into that behavior.
Does it only affect cells below that flag, or the
It does two things. So one, it'll look to see if the widget is coming from site packages, which for Python folks, that is usually an indicator that that's like something that you've pip installed and not something that you're working on locally. So it will usually not start up for production. So if you were working with other widgets, it wouldn't start monitoring those. But in a notebook, any widget that you've defined either locally or in the notebook, it'll start monitoring for file changes for those. Let me boost this up again. Cool. Okay, so we've done our refactor. We've gotten HMR working. And now I think this is fun because now we're starting to get into like sending like drawing something more exciting than a button on the screen, and also dealing with the concept of binary data, which I think many folks here might be interested in. So if you squint at this big block of Python code that I've written here close enough, you can kind of make out that this looks like a question mark. Maybe if you can, it's like you can kind of squint at it. And what I've done is, when I first heard that noise, I thought, okay, it's fun to click a button, but like, what if you could actually have like the little brick that if you clicked it, it jumps up and down and makes the noise, right? So the idea here is just that I've created like a grid of a list of lists in Python that where I've sketched out this 16 by 16 brick of like a question mark in Mario. So if I run this cell, and you can follow and do the same, then below I have a mapping of the string characters that I use to sort of like draw the grid to their RGBA color values. And then with NumPy, we can create a NumPy array that is a 4-dimensional array, which is the width, height, and then the RGBA channel. So now we're going to get back an object, which is going to be 16 by 16 by 4. And if we render that with matplotlib, you'll see that we've created like sort of this image data, but just using kind of strings in Python. And the reason we're not using just like a JPEG here is just because I want to show that we're going to like, we've created some data in NumPy, and I want to like send that to the front end. I think that will be kind of a common pattern of people that might want to work with either some large table data in something like Apache Arrow, or maybe working with some of the NumPy data or multi-dimensional arrays. I think that's probably a big use case for, or certainly something we've observed in the community projects with anywidget. Cool. So one important thing here is that we set the data type of the NumPy array to be a uint8. And that's just related to how pixel values are saved or understood by the web APIs, and also for imaging data, is that usually you encode images as their width, height, and then an RGBA value, which is an uint8 value. So it's something between 0 and 255. And the actual binary representation is important because we're going to send that binary data to the front end, and we need to have a shared understanding between Python and the front end of what constitutes like this image data that we are going to send. So it's not super important that you understand like what an RGBA buffer is. It's just more that like we've been intentional on the Python side that we've prepared it in this way that it's 16 by 16 by 4 and uint8. And on the front end, we're going to use that assumption to put that data into the DOM. So on the front end, we can access the underlying binary data of our uint8 array by converting that NumPy array to its underlying bytes. So NumPy is just a container over a large block, or any NumPy array is a container over a large block of similarly typed data. And so we've created our NumPy array imaging data, and now we're going to call this toBytes method on it to get the underlying bytes. And that's something that SciPy Widgets knows how to serialize to the front end because it's a Python primitive. It's just a bytes. So in exercise 5, we're going to add a new traitlet, and you'll notice that this traitlet is a new data type that we haven't talked about yet, but it's called bytes. And the value that we're going to pass in as the default value is the underlying buffer from that NumPy array. The other thing to notice here as a convention is that I've prefixed this traitlet with an underscore. And similar to Python classes, like this is probably a property of someone that's using this widget we wouldn't want to access because they don't know what this underlying binary data is. And so I'm just putting it behind a flag so that we can still send it to the front end, but it's not something that we probably want our end user API to expose. So it's just a convention. Oops. And I'm realizing in the notebook, I think I have an answer that's referenced rather than the your local index.js. So make sure to change this to whatever version of the JavaScript file you're working on.
You didn't want to put the bytes as a property. You could send it using send.
Yes, exactly. So you could emit it in send. You could do something like as the second argument here to send, you pass in buffers. And so you could similarly call mp.toBytes, or what is it? What do I call it? mpbox.toBytes. And you pass that to the front end. And then in your front end code, in that callback, the second argument here is buffers. So that would be the JavaScript data. So it's separate from the message. So there's a parity of the arguments that you send on the Python side and how you extract them on the.
So what's the difference between putting it as a second argument there versus instead of kind click?
First is serialized.
Okay.
The first is serialized to JSON. The second is a list of binary data. Yeah. And it needs to be bytes or memory view Python objects. Yep. Yeah.
Is that compatible across the board? I feel like when I was working on the Jupyter widget, I started out using the send as the message and ran into a problem with binary data not working
Huh.
or something. I was curious
Okay.
if you've seen like if there'd be any compatibility issues with send or the properties.
I'm not sure with send if I've seen anything. There was an issue early on where SciPy widgets required a custom serializer for binary data, and in anywidget we handle it automatically. So if you try to send bytes, it'll be on the front end. It will unpack it as bytes, but I don't know. Yeah. Yeah. Okay. No, I'll have to look into that in Colab. I'm curious now. Cool. So in this example, I'm going to remove sort of this usage of the send API and just use the traitlet instead. And now in our front-end code, I think the example just said, I just want to console.log that data. So if I go up to the top of my render function here, I can say console.log model.get, and we've called that traitlet bytes. So now if I save that, remember that hot module replacement stuff is working. So if I open up the console, maybe I haven't done it yet. Okay, so now what you see in the console, and let me do it again just so we can see it. The thing that you get back on the JavaScript side from SciPy widgets is something called a data view. And another thing I hope you get out of today is anytime you see a JavaScript object that you're getting, go to the MDM docs and Google what it is. So MDM data view. And data view provides a low-level interface for reading and writing multiple types of binary data. And so we can extract just the raw bytes that we get back from SciPy widgets using this data view API. So the data view allows you to encode things like endianness and things like that if you wanted to. For folks who know a lot about binary data, that might be useful. For the purpose of this tutorial, we don't have to worry about those details. We're just going to grab like the raw underlying UN data array. Cool. Okay, so putting it together, this is probably the most tricky part of the tutorial and has the most moving points. It's just don't get discouraged if it's hard to get it to work, and it's also okay to just skip to the answer, but I do think that you should sit with it a little bit and try to get these pieces working together. But the goal of this next section is to take that binary data that we have and put it into the contents in the document object model, or the DOM. And so this is going to start in 2 steps. The first thing we're going to do is change our button to a canvas element. And the canvas element is a JavaScript element that allows you to, it's a 2D graphics element. So you can put image data into a canvas element, but you can also draw points and lines on a canvas element. It's a very simple web primitive. And in the notebook, I've linked some documentation about what the canvas API is. But it's been around for a very long time, and it's kind of the easiest way to take RGBA data, for example, and throw it into the screen. So that's why we're using it. So similar to how in the first exercise we took our hello world H1 and we changed it to a button, now we want to take our our button and change it to a canvas. So we're not going to have the inner text on that anymore. We just are going to have a canvas element, which still has our event clicker. So whenever we click it, we want to still emit those changes. It's just we've changed it from a button to now this other type of element, which we can put our pixel data into. Okay. So I'm going to go slowly, and the first thing I'm going to do is just change this button. So I'm going to go to where I define what the element is, which is the button, and I'm going to change button to canvas. So that's going to be the first piece. So I'm going to do canvas, and I'm going to rename all these instances a button. So I'm changing to a canvas element. I want to get rid of this inner text because the canvas doesn't have inner text. It's this pixel output area. We want to change our event listener from our button for our new canvas element. And we want to make sure that we click the canvas anytime we get those custom messages. So far I've just changed that. And let's go down to the exercise just so we can see what we're working on. So I have my widget out here, but as you'll notice, I don't see anything. And that's because we've gotten rid of it, but the canvas doesn't really take up any size, and we haven't styled it in any way or added any data to it yet. And so in the code block above, I provide the next step, which is what we want to do is we want to size that canvas. So remember, the data that we're getting back is 16 by 16. So we're going to hard code that's the number of pixels that we actually want into the canvas element. So that's going to be the canvas width and height. And then we're also going to just style that canvas. So we can have a difference between the actual pixels and the actual number of pixels that takes up on the screen. So the canvas width and height refers to the actual data that we're writing, and then the canvas style width and height relate to the actual final pixels that end up being rendered by the browser. So that's sort of the distinction of why we have these 2 different values here. So I'm going to copy that canvas code right underneath where I define the canvas. setting those properties. And now when I save, if I scroll down, we should see that there's now kind of this like blank output. And I think now is a good time to point out that the browser also has some pretty nice ability for us to inspect actually what's going on in this document object model. So if I click this little cursor here in my browser developer tools, I can hover over anything on the screen and see where that is in the document object model. So if I hover over that output, we can actually see that we have this output area. Maybe I need to actually run this. Let's see. If I hover here, we can see we have this output area. And why?
I think you cleared an error.
I cleared an error. Let's see. Button is not defined, so I did not do this correctly. Where is my button? Yes, okay. I did not append it to the DOM, and I have a reference error. So maybe I made the exercise too challenging for myself. But if we save this, now you might have seen it jitter a little bit. And if we hover, you'll see that we have this little brick that's blank, but it's there, and it's in the DOM. We just haven't put anything there yet. So the last step of this somewhat more challenging exercise is that we want to take that binary data and set it as the pixel data or the image data for that canvas. And that consists of these last 6 lines of code before we add the event listener, which constitute of taking our model and getting this data view. So I can follow this side by side. So we're here. We've created our canvas. I'm then going to extract the data view. So remember, we can get our const data view is going to be the model.get bytes. And we then want to pass that data view into something called a uint8 clamped array. So the JavaScript has all these data arrays that allow you to take views over common binary data buffers. So something if you had like float 16 data or float 64 data or big int arrays or U32, like you could actually get a typed array that gives you that view. So you don't have to worry about unpacking those offsets as long as you have like that binary data. And I don't want to get too into the weeds about all that stuff that exists. It's just more that there is more than you probably know that exists to kind of help you work with the various types of NumPy array data that you might want to work with in the front end. But in this case, again, we're working with uint8, which is why we're going to grab this uint8 array. And I'm using a uint8 clamped array because it's kind of for safety, but just it'll truncate things that are above 255 to just be 255 in case I gave it something else. But in this case, we know that the data is uint8, so we could also just use a uint8 array. So I'm going to now get something that I call bytes, which is going to be our new uint8 clamped array. I'm going to pass it the data view and get the underlying buffer from that view. And then the last 3 steps is to create image data. So we're going to create something that is this RGBA image that has a set width and height. So remember, right now we just have the binary data, but we haven't told the canvas or anything yet what the width and height of that data is. So that's going to create our image data. And then we're going to draw and put that image data into the DOM using this context API. So again, there's quite a lot of moving parts here. The thing I just want to impart is that like these are built into the browser. It's a little bit of ceremony because we're not using a special library, but you can absolutely learn these APIs and like build pretty similar things yourself. And the idea is to just understand that we're taking this binary data and we're going to draw it as pixels on the screen somehow in the front end. So now, if I scroll down and I save my file on the left, we should see that we have this brick that appears. And so now we've sort of completed, we've finally done this ceremony, we've completed this element that now if I click this brick, we still have sort of the functionality as before. It's just now, rather than having this like custom button element, we have this canvas which is using the data from the NumPy array. Yes?
If we want to make the image bigger, what?
Yeah, so I'm curious, like, so you've learned the tools to make the image bigger. And I will give you a hint. This is where we set the image currently. So what would you do with what you've learned with how you send state to resize the image or have it set based off of? So you'd add a traitlet. We could add a traitlet here to that maybe we call something like the size, right? So on here we could add another traitlet that we call size. We do traitlets, traitlets dot. We could do an int for it, and we'll say the default size is 30. Let's say tag sync. 30 is small. Let's do 50, and we'll do tag sync equals true. And then in the front end, we want to get the pixel string for that. So I'm going to create a function up top that I can call const get size. And this is just going to be a helper for me to get the current size as a string rather than the integer. So we can do that thing that we learned before and say model.get size, which is our integer value. And we're going to add pix onto the end. So we've created, this is going to give us back that string. So now if I call get size here and here and save, what is, oh, missing curly brace. There. So this looks pretty small. What is going on? There we go. So that's 50. If we made the widget and we set the size to be something else, we could say 100. If we run this, now we have a much bigger thing. Yep. So good question. So there are two different pieces here. So the actual data that we're sending is 16 by 16 by 4. So canvas width and height refer to the actual data pixels that we're putting into the canvas. And the style property here refers to the actual DOM pixels that we want. So this is what we're giving to the browser to say, stretch it out to this size, but we're putting the pixel value. Exactly. And we want to size it out to this size in pixel space. Yep. Okay. So in the last section, I'm just putting that I don't want to, again, like I wish that we'd have more. Today, the idea was to get you excited about maybe writing a little bit of JavaScript. Maybe in a future tutorial, we could do a little bit of CSS, but I don't think today, that might be a little crazy and blow some minds. So today, I just have included an example of how we can use the CSS with a little bit of JavaScript to actually bring this widget to life and give it a little bit more, like, make it more exciting when we actually click on it. So we can add some CSS styles. Probably the most important one that Nazar just kind of mentioned is that we can add a CSS style for this property called image rendering, or we can say that we want to render the canvas as pixelated. So that will get rid of this sort of interpolation from the browser, and it'll look more like a sharp, like pixel value. And then we can add this is some CSS magic, but we can add sort of an animation that when we click it, we can make the brick actually jump up and down. And then from JavaScript, we can apply and remove that animation, and what that will do is that then when we click the button, we can make it jump, and we can turn that off when it's done jumping. So I'm going to take these CSS styles from here, just because I don't want to write these myself, and I'm going to change the answers that we have here as well. I'm going to just do these styles in line here, but similarly, I could create a separate file. So I'm just going to drag and drop these styles into the page. And then the thing I need to do in my front-end code is add the class list that we defined. So I'm going to add onto the element that we get back from Jupyter, I'm going to add this SciPy Mario, which is going to scope those styles to just those elements. And then within this callback handler, this is sort of a little bit of JavaScript magic to set whatever the current animation is to none. So that's going to clear an animation if it's already starting to do the animation, and then rerun a new animation in a tick. And this is just a quirk about the browser will only try to execute whatever happens after this JavaScript frame has finished. So if we set the animation to none and then immediately set it to this bounce, it would only ever get the later one. So this defers the setting of by just like a tick. It's a JavaScript quirk. There's a lot about kind of doing these things to work well with the rendering engine, but believe me, it's just a way that we can sort of apply and remove the styles like kind of easily. So within the callback function that we have over here on the left, I can add this canvas style animation to none and then set the new style animation. And if we go down to our example, oh, I need to get I don't have the traitlet yet because we changed the demo. Okay, so now I have my new size, much bigger Mario block, and when I click it, it does this little fun animation. And remember, because this is a widget, we can do widget.click, and now it has the little animation. We do it from Python as well. So, so the last bit of today's tutorial that I would just want to touch on is, and with everyone, is remembering that now we've built this pretty fun widget that exposes all these different pieces of state that we can interact with other pieces of UI. So notice that in our actual widget, we haven't incorporated a slider, or we haven't incorporated a button. We just have this brick that jumps up and down and does something when we click it. But we can use the existing SciPy widgets ecosystem to create sort of a nice little UI for adjusting the other parameters. So we can link those traitlets, update them, and also have sort of this app that we string together from widgets all together. So below, I'm importing from SciPy widgets. I'm going to create our SciPy Mario widget here. And then I'm going to use some of these widgets that I get from SciPy widgets to create UI for different traitlets. So I'm going to make a button that I call jump, that when I click that button, I want to make the brick jump. I'm creating a button that I want to call reset, which is going to reset the values of the tones back to whatever their defaults were. And then I'm going to create two sliders that I can adjust to set those values when I adjust them. And then there's a little bit of ceremony here coming from SciPy widgets. And what this does is we can link together, which Nazar showed in the first tutorial, we can link the value of the slider for the tone to the widget's tone 1 traitlet. So we're linking those two traits together. We're doing the same thing for the other tone, for the other slider. And then we're registering these callbacks for the buttons. And then SciPy widgets provides us this VBox container, which allows us to sort of stack these widgets all together into one view. So if I run this cell and scroll down, I now have my widget that I can click. And now if I move this slider up, I can click. I can also make it jump with this button, and I can also reset them to their original values by pressing reset. So this is really just trying to show you that you can make the small piece of functionality or kind of package up this piece of JavaScript and then connect it to the rest of this sort of widgets ecosystem.
When would you consider using an SciPy widgets jump button versus doing the JavaScript button, for simple things like just clicking or running a function or basic?
Yeah, that's a great question. I think for things where I just want to trigger something and I can wire that up with SciPy widgets easily, I would do that. I think the trend that I'm seeing with any widgets is that they usually are exposing some sort of interesting functionality from the browser that isn't something that's already exposed by SciPy widgets. So it probably wouldn't be like a slider I wouldn't be making with an any widget, but something that could use a slider as a type of input, I would combine it with.
I guess the styling is a little bit more Jupyter-y rather than the default HTML button.
Yes, exactly. Yes.
HTML-y, I guess? I don't know.
Yeah, that was actually a question earlier as well that I need to look into, is if there's a way to make your things look more Jupyter-style-y too, if you'd like to inherit that somehow. And I don't actually know if there's a way to do that with custom, without, in sort of the way that we've been doing things, which is very vanilla JavaScript. You might have to introduce some more dependencies.
I do know that there are a bunch of Jupyter classes, CSS classes
Okay.
in the browser. So I don't know if it would work in VS Code, for instance, but at least inside of Fairlight, you should be able to just add those classes to the class.
Okay, cool. So that there are a bunch of classes. So if we actually go to, at least so this is part of this challenge with having these multi-platform widgets, is that in one environment there might be styles that VS Code defines that Jupyter Lab doesn't have. So if you rely on things that come from that parent container, your widgets could look different across different environments. So, but I believe if you go in and we hover this button, you can see that there are all these different classes that are on this button that are coming from Jupyter Widgets. So there's this Jupyter Widgets button. I assume that we could add that Jupyter Widgets button probably to a button that we make, and it would style it sort of with the styles that are incorporated there. Yeah?
Is there a reasonable way to have styling, at least have the widget know what environment it's in to adjust the styling? To detect that it's in VS Code?
That would be a great, that would be a great library for someone to implement. I think that would be a great part of the ecosystem if there was some way, like more declarative way of like, these are the different libraries I'm in. Like, can you give me the style, like these common sets of styling that would, yeah. Yeah, so there is in Google, there's a global called Google. So you could always like have a function that just checks the global namespace for Google. I think in the front end. And but the thing is, it's hard to inspect these things because like Jupyter Lab is different from Jupyter. And so but it would be nice for there to be like basically a client library. Like I could imagine a package that you could export that we could implement for the community, which is Colab is something, it has sort of this like more tested set of like helper functions for that type of functionality. Yeah. Yeah.
In this example, we're passing through like a really small amount of binary data. If I want to pass through gigabytes, is there like a best practice there, streaming it or chunking it?
So that might be where you want to reach for something like send, because you can dynamically push data, like add or pull data on the client from like rather than, because the thing that you have with traitlets is it's like data that gets attached to the front end. And so it's sort of like, in a more streaming manner, like send is kind of the API that I would reach for sending like chunks of data. But yeah, I will say that you can send quite a bit of data to the front end, but there is a hard limit, and Kyle would know a lot more about what the browser limits are on binary data. But I think it's 4 gigabytes of memory. But that's per tab in the browser, I believe you can use 4 gigabytes of memory. So, but that accounts for all things that are running on the page, including like Jupyter Lab. So it's probably closer to like a gigabyte or something. I don't know. But.
Or like 100 megs.
Yeah. Yeah. Cool. So that completes like the roundabout of like you're building your first like real SciPy widget and or sorry, your real anywidget that works well with SciPy widgets. And the thing that I want to take out of this today is that we prototyped all of this stuff in a Jupyter notebook, and we started with just like a hello world example and progressed our way up to this like kind of fun but trivial piece of like widget code. But now this is really in a state that we could package it up and ship it off to PyPI if we wanted to share that with others. And there is like more video documentation I've made online about actually going through that process of publishing something to PyPI. But the goal of anywidget is to really go from this state of like, I have this idea, I want to console.log something in an inline string, move it into a separate file, start building that out. And then at the stage where maybe that's something that you want to publish to PyPI, you could do that. But similar to Python scripts in the way that you share notebooks, you could also just share a notebook with a widget in it to a colleague. And it doesn't need to be sort of this production level thing. So it can sort of sit at all aspects of the process.
And that's sort of a key thing, I think some people asked about it earlier, but it was offline, about any widget versus the traditional way to do widgets is you can package all of this as a pure Python package. So the JavaScript code that you ship with your PyPI package is loaded from the kernel. The traditional way the front-end import systems work across all these different Jupyter platforms is that the web server is importing the front-end modules. So in Jupyter Lab and Jupyter, that's happening from the Jupyter server. For VS Code and Google Colab, they need to pull from a content distribution network, which means you have to publish the front-end code to like NPM for it to work. And so this is what like the biggest problem with making it easy for Python developers to publish widgets is you need to know all that front-end tooling and build everything. And with any widget, you could just bundle all the front-end assets with your Python and just publish a regular PyPI package.
Yeah. And the last important thing to mention in that context as well is that the custom Jupyter extensions, like those need to be, if you're using like a MyBinder or some sort of like Jupyter Hub, those are installed by the admins that run the Jupyter Hub, not by the users. And so what happens is if you need to request custom traditional widgets to be installed at the system level across all users. And users can't control their version of a particular widget. With any widget, because the assets are coming from the kernel, the users can install their own widgets. And so you can have, it works much nicer in these sort of shared Jupyter environments as well.
Conceptually, classical Jupyter widgets, each one is a new extension for the Jupyter frontend. With any widget is the only extension that you need. That's sort of the glue code. And now every custom any widget that you make is just leveraging that single extension. It's sort of the adapter module.
Yeah.
To load the frontend code.
Cool. So we'll take a couple minutes, just like that was quite a bit. If people have some questions, I think we'll come back. It'll be a little bit less structured. We've got some questions for you about like today and what you worked on. And then we thought maybe with a little bit of time, Kyle's here and has a cool any widget, and we could have him demo maybe some of the cool stuff he's been building on top of it. So to give you a sense of, we went from sort of these toy examples to like, here's a really cool widget that like is doing awesome things with geospatial data, and maybe get your mind thinking about, okay, we had this like little SciPy Mario thing, but this is also what's possible. So it's sort of spanning the realm of what's out there.
Let's take 5 and come back and we'll just show off a few playground things. Yeah.
Yeah, so there are web APIs that you could, so can you go back to the intro notebook, like intro 1?
Yeah, this would sort of be.
So, if we execute a couple of these cells, I don't mind just running a couple of these, so that we want to get down to the alt there. We scroll down to this one here. So they have implemented this little button up here. This is a JavaScript library that has like some functionality to take whatever in this canvas and export it to some of these formats. So it's not something that comes out of the box with like some of the APIs we talked about today, but you can add that kind of functionality if you want to. I see what you're saying. Okay. So your widget can, so the way that, and we didn't chat about this today too in depth, but so for a class you can just implement this like __ rep, like, which defines like the text object. And then you can also define like HTML, like for Jupyter there are different representations, and one of them that you can export is this _image, or something like that. And what you do for the particular object that you implement is that you can add on all the different types of renderers that it supports. And so an environment that supports the widget, it will render the widget. But an environment that only supports the image will fall back to the image display. So the method to look for is called connect. So if you do underscore RE, and then you use all the there it is. So if you call that method, so just call this method. And
right? That's easier. Can you just do parse dot head? Yeah, and then closing. It's so that if you rerun this, it will just see smaller output. And so you can see this is we get back a dictionary that has text HTML, but also could return something like image JPEG. And that's how it declares, I support a widget, I support this thing, this is the method. So if you wanted to add an image renderer on top of your widget, you could subclass and override Trevor meme bundle and add the image.
So specifically,
In Jupyter, yes. IPython and IPython. Yeah. I see. Yeah. So I think you could hook in probably to that and override it with the image.
message custom.
Yeah. Yes, yeah.
Is he, if I can chance, is he here?
I don't think so.
Okay, man, I'm sad, 'cause I want like his autograph or something. But yeah, so there's some really interesting things I was initially showing.
Yeah, it uses a library called super. Like it's doing parsing. So one challenge is like if you were to use like use syntax that's not you can't actually use it.
Yeah,
So
there's this
we've kind of like taken a stance anyway. There's also IPy React, which does something quite similar. It transforms the JavaScript on the front end. The stance I've taken so far with anywidget is I would like any of the transformation that we can like Python. Because the thing that I believe we should be shipping to the browser is like the final reset. There's no further processing. So I think we're doing some projects to like incorporate more of these like transformation steps as like a years ago stuff on the server side, but nothing for user. Oh yeah.
Cool.
Since yesterday was the last day.
You guys have 10 minutes left, so we'll want to give Kyle a chance to show off what he's done. But we also quickly wanted to talk about many people who don't have any web experience or very little web experience probably ended up playing with a framework like React, because you were told that that's the cool thing to do. And these frameworks are really powerful, but I think what we were aiming to do in this tutorial was sort of make you understand a little more of the fundamentals so you're comfortable with them, and you can graduate to these powerful frameworks when you need them.
Yeah.
And the way you can do that, if anywidget, so the philosophy of anywidget is really what needs to be consumed by the front end when you send the widget module from the kernel. The front end should be pure JavaScript to AFM. Yes.
What's that?
My-
Oh, yeah. So,
And just to finish it, I guess the philosophy behind anywidget is that what you do send to the from the kernel to the front end should be an ES module, anywidget front end module. So it should be pure JavaScript. It should have the anywidget lifecycle methods. It's nothing that needs to be compiled, transpiled, right? Those transformations shouldn't be happening in the browser. There are hacks to do that. But if you do want to start to graduate to this more advanced front-end tooling, you can do that. But it does require now that you would write React, TypeScript, these new, use these frameworks and do the transpiling or do the build step locally. produce AFM, and then that's what you will ship. That's why you can still ship a PyPI package with pure AFM. And so in AnyWidget, this concept is called, we call them bridges. So Trevor's just going to quickly demo the idea of a bridge, so you can write your AnyWidget front-end code in like React, for example, but then basically ship AFM.
Yeah, so I mean, maybe taking one step back, we demoed some prototypes in notebooks today, but like what would you do maybe if you already knew I want to make like a package? Like what type of package manager should I use? Like all that kind of stuff. AnyWidget comes or has a built-in CLI that's called create AnyWidget. So you can do, if you, it requires having NPM or a node instance to actually run it, but you can run NPM create AnyWidget AnyWidget at latest. And what this will do is it'll bring down from NPM like the latest version of this bootstrapping CLI, and it'll ask a couple questions. So like, what kind of project do you want to make? I'm going to call this project IPyFoo. And it's going to ask a couple questions. So would you like to do it in vanilla JavaScript, or would you like to do it with React? If you do it in vanilla JavaScript, you don't need any node or anything to like actually make that package. You can just start right there. If you want to use React, it will bootstrap a hybrid JavaScript Python package that has sort of all the build setup for you to make creating an AnyWidget using the React framework. So I'm going to do it with React, and just to show that it can do all of this, I'm also going to choose TypeScript. So I'm going to do a React app with TypeScript, and I can go into that project, which is called IPyFoo. And then in this project, you'll see that there's a couple files. There's JS folder, which includes the JavaScript source files, source, which is the entry point for my Python package, and then a package.json for defining like the JavaScript dependencies, and a pyproject.toml. So I will open this up in code. OK. If I go to the example.ipynb here, the first thing that it told me to do in the CLI was to, in my package here, I'm going to run npm install. So this is going to install like React into this package. OK, and now I'm going to run npm run dev. And what this is going to do is it's going to start a server to, or a build step to watch the files of the React files and automatically update them for AnyWidget. So now if I go to the notebook, I can run this notebook. It's going to ask me, do I want to make a Python environment? Let's see which Python I want to do. Yes. Change current. Let me change the kernel. What's going on? I want a different one. Select another kernel. Create a Python environment. OK, I'm going to use VM with this version of Python. And I want to install the development extra installs, because that's going to bring in that AnyWidget hot module replacement stuff. So I'm going to create this Python environment, which hopefully doesn't take forever. OK, and now in this notebook, I can run this cell. And the starter is this sort of like counter widget. And now I can open up my widget.tsx, which is my TypeScript file that's in this other folder. And what Nazar was just mentioning is that we have these different, we call them bridges for connecting these different popular front-end frameworks with AnyWidget's sort of like ES module syntax. So you'll import from this AnyWidget React thing. And then using the AnyWidget React library, you can use something that feels much more React-like, but does that adapter layer to the AnyWidget AFM. So it's really just this layer on top of that standard. And then you can write things that are much more React-like here. So now if the count is 5, I can do like make count uppercase and save. And now it's changed over here on the left as well. So it's really meant to just like bootstrap this. And if I have done all this correctly, I could just at the end of this run hatch publish or hatch build and hatch publish, and it would publish it right to PyPI. So it sort of is trying to get you on the right foot of if you want to use some of these things, it's done the setup for you in a way that hopefully is agreeable. So, yeah.
We have 5 minutes left, so let's.
Yeah.
Kyle, if you want to show us a little.
Yeah, so as I mentioned, I mean, Kyle's been doing some of the coolest work, I think, with anywidget from some of the community members, and is really making use of that final thing that we talked about today, which is this binary data transport. And so I'll just turn it over to Kyle to sort of show you what you can actually do with anywidget. Yeah.
Well, I don't really have anything planned, but I can demo.
It might take a second to get it.
Yep.
Let's see. Okay. And where did I have this? I will pull something up so kind of try and see both sides. So this, I have a talk on this on Friday, so you can come see the full talk. But just want to give, I guess, a couple minutes before lunch of showing how this uses anywidget. So this is using. Let's restart the kernel. Is this too small for people? How about? How about that? Should be better. So this is using, this is a library called Lawnboard that does geospatial vector data visualization and uses anywidget pretty heavily. And I'll run through a couple of these lines to see that this is a DataFrame that has 3.2 million rows where each of these are points and some download speed associated with that. So here, I have some methods. This is building on top of anywidget, and I can render all 3.2 million of these points in a couple seconds. And so there's the key to this is that this is using binary data on both the Python side and over the connection between Python and Jupyter, and then also on the client side where this is actually rendering in the GPU. Just because this looks kind of ugly and black, we can run a couple more cells and set the fill color and the radius of each point so that this is download speed around the world from Ookla speed test data. You can zoom in, look at some data, hover over it. But all of the data transfer for anything that is more than like a single number or a single scalar is binary. So this uses Arrow and Parquet, some recent binary data specifications to make this a lot easier. And so even some of these helpers where this, for example, this download speed, if we look at the original GDF, GeoDataFrame, we have this download speed in kilobytes, and then we can convert that pretty quickly using NumPy into this array of download speeds that is linearly scaled between 5,000 and 50,000 kilobits per second. And then with NumPy, pass that into if we run this cell, this gives us a NumPy array of all of these colors. So this is a red, green, blue, and alpha value for each of the rows in the entire GeoDataFrame. And then this is also binary. So we can assign this onto this traitlet on this layer. Inside the layer definition, I actually convert everything from NumPy or pandas into arrow objects. So then this is an arrow object that is saved on the widget itself. And then that is serialized as Parquet over the WebSocket. And so if we look at, this is all open source. You can look at like this serialization file where this does a lot of the work in how it actually does the custom SciPy widget and anywidget serialization. You can look at these custom traits that are custom traitlet objects where you can set the custom to JSON and from JSON methods for sending binary data across Jupyter. And so this is using the WebSocket instead of converting anything to JSON. And then I guess I'll show on the JavaScript side. We also have this, I don't know exactly where I do the deserialization at the top of my mind, but if you're interested in looking at how we do this binary data serialization, you can come talk to me.
Also, this is TypeScript and
Yeah, so this is an example of using TypeScript and React with anywidget. And so this use model state is provided by anywidget that lets you access these attributes from the Python side that are defined. So like here, if I go to this Python file, I have this anywidget subclass where I define, say, this view state for how what the view of the map should be, where it should be centered, and what kind of zoom it should have. And then somewhere, view state. That's maybe not the best example, but I can take this map style, log that, and then on the front end, I can see this console. I just logged this style, so I just saved the file in my editor. I have watch on, so anytime I save it, it'll reload the anywidget. It'll rebuild the anywidget. I have the anywidget HMR environment variable set, so then anywidget sees that was loaded. Let's reload the JavaScript, and then you can see that I am logging in the console this piece of text that I sent from the Python side. That's probably good.
So this is like I mean, look at the number of files. Like it
Yeah.
can build like very real things as well. And I
but you
think
don't
that,
have to start with this.
yeah. But I will say also, like, we've had some discussions, I'll go towards the microphone. But in general, like, we think that there are probably a lot of opportunities to try to figure out the best patterns for like these common data structures or data sources on the Python side, and try to lift those up into reusable libraries to make it easier for other people to build on top of widgets, or both on the Python side and on the front end for using things like Arrow or NumPy, and less of that having to be something manual that you keep in your code base. We'd like to move that into community projects. So, yeah.
And in this very modular way, you can see that what you learned today when you were using the low-level model.set, model.get, what you're seeing in the React bridge is just an alternative way of doing the same thing. So using model state is treating the traitlets as hooks in React. And so, but under the hood, what's ultimately happening is exactly what you did today. So it's calling model.set, model.get. That's what it gets translated into. And so, and learning the fundamentals means you'll understand better what's going on when you start using these more convenient abstractions.
Cool. Well, thanks everyone. Thanks for coming to the tutorial. And yeah, cool.
Yeah, thanks guys. Grab more stickers. Please leave some feedback for
Thanks,
us.
Kyle. I really put you on the spot.
We'd love to learn what it's like, what you could have improved on.
Yeah, I really put you on the spot. I mean, it's just more like I can send binary data. So.
Like you can send if you have something that actually